time, so we can start sharply at 3:30. There were 30 odd people voted that they will join, but they're not here. Okay, then before starting, let's make a small agreement. Okay, the agreement is that for the next 3 hours, we should actually get the maximum out of this seminar. Okay, deal? That means I'll give my fullest from my side, so I expect the same from you, which also means you should not be chatting in between the during the class. Okay, you can be answering questions, you can be texting me, and so yeah, this is you. This should be a safe place for you. So don't be shy. Uh, so please interact with me, ask questions, answer the questions which I ask. Even if you feel your answer might be wrong, it's fine because no one is judging or mocking anyone here. We are all here to learn. Okay. And then, as you all know, throughout the seminar series, we'll be choosing the most active participant. So, which means someone who engages, asks questions, and actually tries. So, yes, and as you know, we'll be posting it on our socials too. So, participate like you mean. And also, let's also decide to stay till the end because it's only 3 hours and with exams so close, you should be honestly be more energetic than me. Okay, so yes, we'll be um, staying till the end. Okay, uh, and yes, there's only few more days left for your levels, and so don't stress about it. We can do this. Even we can have fun while doing this. But the real work still has to happen even while having fun. Okay. Guys, text me. So yeah, deal now. Like you'll get the maximum from this seminar. You'll give your fullest. You'll ask questions. Deal, deal. So how's chemistry for you? Is it hard comparatively while comparing it to physics or bio? How is it? Oh yes, physics is much easier. Okay, so when I was doing O level also, I found chemistry the hardest one. Comparatively, than physics and biochemistry was hardest for me. So I thought that it will be the same for you all also. So yeah. And since most of you requested it, today we'll mainly focus on electrochemistry and quantification lesson. So yeah, quantification is mostly based on calculations. No, and electrochemistry there are many theories too. So and also I have planned a few activities, and if there's time, we'll move on to other lessons, and especially you all had voted mixtures too. So we'll see how it goes. Where are the others? I'll be starting sharply at 3:30. No delays. So yeah, call your friends. So is this time a problem for you all? I mean, any school time or something? You all have after classes or anything or something like that? You all can hear me clearly, right? There's nothing I should adjust before the class starts now? Mm, thank you. Maybe some of you all have joined the live stream also, no? YouTube live stream. It is like 30 odd people who voted that they'll be joining. Yeah, but there's only 30, not even 30. So only 60 odd people had voted electrochemistry and quantification. Actually, what do you all find hard in it? What are you struggling with in electrochemistry or the quantification lesson? Can you all let me know so that I can focus more in? What is this, guys? So now you all should have known this very much. This should be like your family member. It should be so familiar with you. So yeah, same. What is this series? Only where are your responses? Text me, text me, text me. Yes, so this is the reactivity series, no? So this is very important in electrochemistry as well as in many other lessons like, changes of matter. So yeah, you study about this in changes of matter. Then yeah, this is also important in electrochemistry also. So I have written it here for my convenience. And yes, this is my contact number. If you all are not joining in Zoom, sorry, wait. You can text me through this also. So yes, save it. Soon. Okay. So yes, we'll start. So yeah, get your tubes if you have got the tube printed. Uh, yeah, you can get it or else you can use your PDF because I cannot be sharing because the ones joining to YouTube they'll not be able to see it if I share it. So yeah, you all can open it. So yeah, the first question we are going to see is the MCQ 12. That is from the quantification lesson. MCQ number 12. So yeah, read the question with me. The relative molecular mass of the hormone adrenaline is 183. Relative molecular mass. So this is, I write it as RMM, but it's actual, the symbol is MR. MR, simple R. This is relative molecular mass. Okay, of hormone adrenaline is 183. So if they have given the relative molecular mass, first of all, you need to know they are talking about a molecule. It's not an atom because they have given the relative molecular mass. If they are talking about an atom, they'll be giving the relative atomic mass. Okay, so the relative atomic mass is AR. This is relative atomic mass symbol. So yes, therefore, and they are asking X in the relationship 183 is equal to mass of an adrenaline molecule over X. So in that equation, they are asking what is meant by X. Okay, so before that, first of all, we need to know what is meant by the relative atomic mass or the relative molecular mass. So, so in chemistry, we are dealing with atoms, molecules, compounds, elements, and all. So to measure the mass of an an atom is a atom is very small. No, we can't even see it with our naked eye. One atom we can see it, right? So it is very small. So to measure the mass, they can't use like the units like grams or kilograms because they are very large when comparing to the mass of an atom or a molecule. So even the smallest gramic unit, which is called the attogram, we say Ag. So attogram that is also larger when comparing to an atom or a molecule. So therefore, scientists thought of doing something different to make it easier to make it convenient for us and for the calculations and all. So what they did was to make the calculations easier, we can measure it using grams or attograms or others. But yeah, if we measure using it grams or something, it will be like it will come in powers of negative 10, like 10 to the power minus 26, 23. So which means it is very small, no? 10 to the power minus 26 means you have to move 26 decimal places back. So it means 0.000 like that. There should be 26 zeros. So that means it is a very, very small value. And when we are dealing with the questions, it will be hard for us. So what they did was they chose a standard unit called the atomic mass unit. They used a standard unit called atomic mass unit. So with relative to this unit, they express the masses of other atoms or molecules. So that is called the atomic mass unit. So they chose the atomic mass unit as the 112th. 112th the mass of carbon 612 isotope. They choose this mass as the atomic mass unit. That means uh, they took the mass of this isotope. So what is an isotope? Which means so carbon has several isotopes. So carbon atomic number is 6 and its mass number is 12. So isotopes means the atomic number should be the same, which means the same element, but the mass number would be different. That means there would be different number of neutrons, right? So there are carbon 6, you don't need to know this, but yeah, there are carbon isotopes like carbon 613, carbon 614, and all. But they chose the isotope carbon 612, and they measured the mass of this isotope, and they divided it by 12. They divided it to two pieces of 12, and they use one piece, and they compare it to the other atoms and molecules and all. So like if this is the atomic mass unit, if this is the atomic mass unit, and this is some other molecule, okay, some other molecule or an atom. So they said it like this molecule is 12 times greater. The size is 12 times greater than this one. So like that, they compared it and they expressed this relatively because this is much more easier than dealing with the negative powers and all in the questions. So yeah, this is 1. Then I can say this is 12, or if this is 13 because this is bigger. This time this much bigger than this, something like that. So they took it as the atomic mass unit. And if they express the mass of a molecule that way, we say it as relative molecular mass. Okay, we say it as relative molecular mass. And on the other hand, if we express a mass of an atom that way, we say it as a relative atomic mass. Simple as that. Okay, so this is AR, that is relative atomic mass, and MR is relative molecular mass. So what they have given here is relative molecular mass of hormone adrenaline. Like, yeah. So if I have to get the relative atomic mass of an atom, like if just I'm choosing magnesium atom means if I have to get the relative atomic mass of it, then I have to divide the mass of this magnesium atom by 112 the mass of carbon 612 isotope, which means I can say it like mass of carbon 612 divided by 12. That is 112 the mass of carbon 612 isotope. Okay, so then I can compare the mass of magnesium with this and with this atomic mass unit. I can give the relative atomic mass of magnesium. Okay, so and if I'm dealing with a molecule like H2O, H2O is water. So yes, as you all know, H2O is water. So if as this is a molecule, we express it as relative molecular mass, not atomic mass. Okay, so they have given that. So yeah, they will be giving the mass and all. You just have to do the calculation. So they have given that the mass of H2O is 2.99 into 10 to the power minus 23 grams. Okay, they have given it in grams. So yeah, see, we have got a negative 23 power. So, and they have given the mass of carbon 612 isotope, that means the atomic mass unit, that as 1.66 into 10 to the power minus 24 grams. Now, if I have to find the relative molecular mass of H2O, what should I do? Just divide the mass of H2O by this atomic mass unit. So it goes like 2.99 into 10 to the minus 23 grams divided by 1.66 into 10 to the minus 24 grams. So this minus 24 can can get cut with this minus 23, there would be a 1 minus remaining here. So 10 to the power minus 1. And I can simplify this. And then the answer would be like 1.8 over 10 to the power minus 1. And this 10 to the power minus 1 goes up. And therefore it becomes 10 to the power 1 plus 1. Therefore the answer would be 18. So this is the relative molecular mass of water. So instead of dealing with masses like this, which is comparatively harder, we can deal with the masses like this now. So because of, for our convenience, they did it this way. They introduced a concept called the relative atomic mass or the relative molecular mass. Okay, so now in the question that they have given here, they have given the relative molecular mass, which means adrenaline is a molecule. So the relative molecular mass is given as 183. Okay, so they're asking X in the relationship. So 180, they have given the relationship also, which is very easy then. So mass of an adrenaline molecule, one adrenaline molecule divided by X. So they are asking X. So what is X here? So X should be the atomic mass unit, the mass of the unit which we relative to which the other masses of the molecules or atoms are expressed. That is the relative atomic mass. So that is equal to 1/12 the mass of carbon 612 atom or isotope. So if we say it, we can say it as an atom or isotope because there are other isotopes. They have given it as isotopes, but yeah, isotopes are also atoms, no? So yes, we can use it as atom or isotope, whatever. So this is not hard. You just have to do the calculations correctly. So then it would be easier. So the answer would be second one, right? The answer is second one for the 12th question. Clear? All clear? Teacher, can you speak a little louder? Can you hear me? Is everything clear? Yes. Okay. Is there any doubts in this question? This is an easy one, no? Please respond so I can move to the other one. Okay. So, and also you should also know that the relative molecular mass of a molecule is equal to the sum of the relative atomic mass in that molecule. Sum of the relative atomic mass in that molecule, uh, which means now if I take the molecule water, which means H2O. So there are three atoms here now. There are two hydrogen atoms and one oxygen atom. So if we find the relative atomic mass of hydrogen and oxygen, we can also find the relative molecular mass of this water. Which means the relative atomic mass is given of hydrogen is given as 1. Okay, and the relative atomic mass of oxygen atom is given as 16. So if they have given these two information, then we can find the relative molecular mass of water. How can we find? Just by adding. So here there are two hydrogen. So therefore, which means 1 into 2. 1 into 2 plus 16. There is one oxygen, therefore plus 16, which is equal to 18. So yeah, we can get this way. If they have given the relative atomic masses of the particular atoms in that molecule. Okay. So you don't have to be confused with relative atomic mass and relative molecular mass. When you are dealing with atoms, then you are using relative atomic mass. When you are dealing with molecules, then you should use the relative molecular mass. Okay, right? Now, uh, now we'll go for an electrochemistry question. So for that, you should turn to the page number. Wait. We'll start with an essay because then I can introduce the electrochemical cell and the electrolytic cell. So the essay number, sorry, yes, essay number one, not structured essay, essay number one, part B, part B. So that question was a bit unclear, but yeah, I'll guide you through this and we can do this together. Yes. So yes. So as you all know in electrochemistry, we are studying about two types of cells, right? Electrochemical cell and electrolytic cell. So these are two different types. So first of all, you all need to know how to distinguish an electrochemical cell from an electrolytic cell. Okay, and then if you just know the steps that you need to follow to approach that question, which is based on electrochemical cell or electrolytic cell, you can use the same steps anywhere else, which means any type of an chemical cells or an electrolytic cell, you can use the same steps and get the correct answers. So you just need to know certain steps. So I'm going to teach those steps here using an electrolytic cell as well as an electrochemical cell. So while I teach this, so I'll be saying it step by step. Like you should do this first and then the next. So you all can take the notes according to it. Like step wise, you all can take the notes. Like first, you all have to do this. Second, you all have to find this and all. Okay. So yes, so they have given a diagram here, right? So the diagram shows. So okay, the essay number one, part B. So the diagram shows two sets of apparatus A and B prepared by a student for a laboratory activity. So here they have given two apparatus, as you all can see, which are made up of, they have used the lid of a plastic bottle as a container and they have filled it with dilute H2SO4, which means H2SO4 mixed with water. H2SO4 plus water will give dilute H2SO4. If there is only H2SO4, then we can say H2SO4. And if it is concentrated, we can say concentrated means there is a much high concentration of H2SO4. Then we can say it as conc H2SO4. So they have filled it with dilute H2SO4. And in the apparatus A, they have connected it with a dry cell. In the apparatus B, they have connected it with a small motor. And they have used rods also. Okay. So as you all can see, you all can definitely understand that these are two types of cells. They should be either electrochemical cell or electrolytic cell. Okay. So the first question is, name the scientific experiment that can be done using the above apparatus. Name the scientific experiment that can be done using the above apparatus. So yes, if we see these two apparatus, first of all, you need to distinguish whether it is an electrochemical cell or an electrolytic cell by a single glance. You will have to see it and you will just have to notice it like this. Okay, this is an electrochemical cell and this is an electrolytic cell. How can you do that? Okay, so now I will say how you should approach this question. So first of all, in the apparatus A, they have connected a dry cell. In the apparatus B, they have connected a small motor. So there These are the differences between the two cells. So the difference between an electrochemical cell and electrolytic cell is that in the electrolytic cell, there will be wait a minute. So in the electrolytic cell, they'll be using the electricity. Okay, and in the electrochemical cell, the electricity will be produced. Those are the main two differences. In the electrolytic cell, they'll be using the electricity, and in the electrochemical cell, the electricity will be produced. Okay, so yeah. In what apparatus do you think the electricity is being used and not produced? Is it apparatus A or apparatus B? What is it? The electricity is being used and not produced. Which apparatus is it? Can you all say?
It's A.
Please text me. Don't unmute, okay? Page number, wait, page number 11, part B. A, yes, exactly. Good for her. Others? Yes, it's A. How can you say that? Because it is connected to a dry cell. When it is connected to a cell, the cell produces electricity now. So here, the cell produces electricity means the cell is using that electricity which is produced by that electrolytic cell has been using the electricity produced by that dry cell. And in the apparatus B, they have connected a small motor. So motor is not producing electricity; it should be using. That means the apparatus B should produce electricity, and that will be consumed by the motor. Okay. So now in that case, uh, I'll do it here. This is A. Okay. They have connected a dry cell. So these are the terminals. This is a negative terminal, positive terminal, and it's connected like this. And in the B, the same. The rods are different. They have used copper wires, iron wires, and they have immersed it in dilute H2SO4, and they have used a small motor. I'll name it as M below. A small motor is connected. Okay. So the difference between electrolytic cell and electrochemical cell is that in the electrolytic cell, the electricity should be used by that cell. So that means we should provide the electricity. So this is the positive terminal and this is a negative terminal. We are providing electricity by using a dry cell, and then there will be a chemical reaction taking place within the cell. So that means we are converting electric energy to chemical energy. We are converting electric energy to chemical energy. That is an electrolytic cell. So that means we are providing electricity for a reaction to happen. That means that reaction is not taking place spontaneously. We have to provide energy to do it. So that is done in the electrolytic cell. By the way, in the electrochemical cell, they have used a motor. That means here the electric energy have to be produced. Electricity or electric energy has to be produced. Chemical reaction that is taking place within the cell, there should be electricity produced, and that should make this motor work. That should make this motor work. So that means in the electrochemical cell, chemical energy is converted to electric energy. In the electrolytic cell, electric energy is converted to chemical energy. So the first step in distinguishing electrochemical cell and electrolytic cell is to check whether it is connected to a dry cell or it has connected to an appliance which is using electricity. So the motor will be using electricity to work, right? So if it is connected to an appliance that is using electricity, that means it is an electrochemical cell. The chemical energy is converted to electric energy. On the other hand, mostly there would be a dry cell connected. Yeah, mostly a dry cell would be connected because that would be producing electricity, or a battery, some kind of a battery, which is producing electricity should be connected to the electrolytic cell. Then that cell would be using the electricity produced by that dry cell, and there will be a non-spontaneous reaction taking place here. Okay, so that's how you should distinguish it with a single glance. Okay. So they are asking, the first question is they are asking to name the experiment. So in the A, it is electrolytic cell or electrolysis. And for the B, it would be electrochemical cell. Electrochemical cell. Clear, right? All clear? All clear? Any doubts? A is electrolytic cell, A is electrolysis, and B is electrochemical. Electrochemical cell. So which means if there is a source of electricity connected, if there is a source of electricity, mostly that would be a dry cell, okay? Mostly that would be a dry cell. If a dry cell is connected, that is electrolysis, which means it is using electricity. And on the other hand, if an appliance which is using electricity is connected, then that is electrochemical cell, which is the apparatus B, is an electrochemical cell here. Okay. So yes, we'll go to the second one. Second one says that name the parts labeled X and Y, but they have not labeled it here. Okay, so can you name that iron wire as X and copper wire as Y? Mark an arrow and name the iron wire as X and iron wire in apparatus B and the copper wire as Y. Copper as Y. So yes. So they're asking to name it, which means you're not gonna name it again as copper wire or iron wire. They have given it already. So which means they're asking you to name me. They're asking whether it is an anode or a cathode. That's what they're asking here. They're meaning here. Anode or the cathode. Okay. So yes. So then first of all we'll look at the apparatus B. So I'll write the apparatus B. What is the apparatus B? It is an electrochemical cell. This is copper and this is iron. Iron is Fe. And they have connected a small motor here. So yes, as there is no dry cell connected, but an appliance which is using electricity is connected, this is an electrochemical cell. That is the first step that you will need to identify. Okay, and then they are asking about the cathode and the anode. No. Yes, so what is anode? Anode is the site where the oxidation takes place. And the cathode is the site where the reduction takes place. So anode is the place, that is the only thing you need to know about anode and cathode. Anode is the place where oxidation takes place, and cathode is the place where the reduction is going to take place. Okay, so first of all, to identify which species is going to oxidize or reduce, first of all, you need to understand what are the species present in this entire cell. First of all, we need to name all the species present in. As we all know, as they have given copper and iron here, there is copper, iron here. Other than that, here, here, there is dil H2SO4, no? So which means that dil H2SO4, H2SO4, the whole molecule, will be breaking down into it cations and anions in the electrolyte. So this is an electrolyte. What is an electrolyte? Electrolyte is a liquid or a solution which is able to conduct electricity. If it can conduct electricity, then that is called an electrolyte. So ionic compounds, the molten, you mean molten means the liquid, okay, or the solution. Solutions of ionic compounds can be used as electrolytes, or other than that, the aqueous solutions of acids like DH2SO4 and the aqueous solutions of bases can also be used. But the covalent compounds cannot be used as an electrolyte because the covalent compounds, they are not the conductors of electricity, right? In any forms, they are not conducting electricity or heat. Okay, so here H2SO4 in the solution, it will be breaking down into its respective cation and the anion, which is H plus and SO4 2 minus. So H plus and SO4 2 minus has combined together to form H2SO4, and that will break down within this solution. So there will be H plus and there will be SO4 2 minus ions too. And then as it is diluted, there is water also. So whenever there is water, the water will be breaking down into two. Water will be breaking down into its respective cation and anion as H plus and OH minus. H plus and OH minus combines to form water. Okay, so H plus will also be there. We have already marked H plus here because it is coming from both water as well as H2SO4. And then there is OH minus coming from water too. So these are all the species present in this respective cell. So first of all, you need to know all the species present in it. Okay, so the next step is to identify which species can undergo oxidation and which species can undergo reduction. Oxidation and reduction. Which species can undergo oxidation and the other one which can undergo reduction. So for that, oxidation. Metals, they always like to oxidize. Metals, like this copper, iron, all the metals, as you know, it is the chemical property of metal to form positive ions, which means they are oxidizing to form positive ions. That means they are losing electrons. Metals, they never like to gain electrons. Keep that in mind. Metals, they never like to gain electrons. They always like to lose electrons. That means they always like to oxidize. So when it comes to oxidation, the first priority should be given to the metals. Okay, so here copper and the iron, they will definitely come under the oxidation because they are metals. Okay, and when we consider H plus is already having a plus charge. If it oxidizes further, by losing electrons and electrons, then it will become more plus. No, H plus don't like it. It doesn't like it because someone who has a positive charge doesn't like to become more positive. It likes to become negative by gaining. And someone who has a negative charge, it doesn't like to reduce more. Okay, so it doesn't like to increase its charge in the same way. Okay, so H plus will never like to oxidize again because it is already oxidized to form a plus ion, right? It is already positive. If you oxidize it, it will become more and more positive, and H plus is resistant to it. So yes, H plus cannot come under the oxidation. It will like to reduce. H plus likes to reduce. And then SO4 2 minus and OH minus, they have negative charge, which means they are already in a reduced way. They have gained electrons and they have become negative. So will they like to become reduced again? Will they like to become more negative? No. They will like to become more positive by losing electrons. So they are also coming under this oxidation. So yes, these species can undergo oxidation. All four species can undergo oxidation and reduction. H plus can undergo reduction. Okay. So yes, as there is only one species here to undergo reduction, definitely H plus is going to reduce here. But there, in oxidation, there are four species to undergo. They are competitive. They are competing to undergo oxidation. So which one will undergo oxidation first? It's not the negative ions. I said the first priority for oxidation should always be given to metals. So you can cut these two because they are not metals. The first priority for oxidation is always given for metals. So that is copper and iron. And among these two metals, which one will undergo oxidation? For that, we are using the reactivity series. So whenever we are dealing with metals, whenever we are dealing with the reactivity, we are going to use this series. They have given the series here. So as you know, most of you all have memorized it. And there are easy ways to memorize, like mnemonics can be used also. So yeah, the mnemonics AHIUC, potassium. So this is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, and this is mercury, aluminium, sorry, silver, platinum, and gold. Okay, so the mnemonic which I use here is please stop calling me a zombie. Instead, try learning how could Monica sell pretty gold. How could Monica sell pretty gold? So I thought of Monica Bellucci and I decided it the M as Monica. So here the Monica is not dancing or acting, she's selling pretty gold. So you can remember it that way, or if you all have any other ways, you can use it too. Like, please stop calling me a zombie or zebra. That was given in the Google. Instead, try learning how could Monica sell pretty gold. Okay, so you all can use other mnemonics also. Either way, the goal is to keep that in mind. Okay, so when we use the reactivity series, when we are comparing two metals, according to the reactivity series, the metal which is above is going to oxidize. So that means the ability to oxidize increases when we are going up. The ability to oxidize increases when we are going up. And the ability to reduce increases when we are going down the reactivity series. Okay, so ability to oxidize increases when we are going up. That means the metal which is above is going to oxidize. And the metal which is going to be down, that likes to reduce more. Okay, so here when we consider the copper and iron, here is copper, this is copper, and this is iron. Which one is above? Definitely, iron is above. Then who is going to oxidize? Iron is going to oxidize. So whenever you are comparing the metals or other species in the activity series, you can compare it to decide whether which one will oxidize or which one will reduce. Okay. So yes, here iron is gonna oxidize. Okay. So then we have found that this particular person, iron is gonna oxidize. That means where is the oxidation taking place? At the iron wire, at the iron electrode. So oxidation is taking place here. Okay. Which means that is the anode. That is the anode. So yes, as I marked X, no, X, right? I said X as iron. Yes, so iron wire would be the anode. So if an electrode becomes the anode, definitely other one will be the cathode. Cathode is the site where the reduction places. So that should not be copper. I mean, copper is not reducing here, but the reduction is going to take place near the copper electrode. Okay, so this H plus is going to reduce near this electrode here. Therefore, copper becomes a cathode. Okay, so you all have to find a cathode and anode according to the rods they have given. So if you find the anode or the cathode, then the other one is definitely would be the anode or the cathode, right? So yes, here. So now we found that. here iron, Fe is going to oxidize and H plus is going to reduce. Now we see what happens here in an electrochemical cell. In an electrochemical cell. So yes. Wait. So yes. Now oxidation. So oxidation is going to take place by the iron. So oxidizing means losing electrons and becoming positive. So iron is here. This is iron. Iron solid, right? Iron solid is here. It's going to oxidize by and it should lose electrons and becoming more positive. So iron likes to form 2 plus ions. That means the iron's charge is 2 plus. So most of the ions which you are dealing with in your syllabus has plus 2 charge. Except for some ions like Ag, silver likes plus 1 charge. So here in electrochemistry, I don't think they'll be giving silver and all. They are giving mostly the plus 2 ions which form. Okay, and the gold will be not forming plus 2, I guess. It would be forming plus 3 or plus 1. You all don't need to remember that because most of the ions that you're dealing with in your syllabus and in the electrochemistry, those are the ones which forms plus 2 ions. Okay, so like iron, zinc, aluminium will form plus 3. So yeah, in that case here, the first 20 elements in the periodic table, they will be forming their respective ions according to their valency. So I will be teaching it when we are talking about the periodic table. Like Mg will be forming Mg2 plus, aluminium will be forming plus 3, calcium 2 plus, Na plus, because Na and potassium are in the first group, they will be forming plus 1. Calcium and magnesium are in the second group, they will be forming plus 2. Aluminium third group, it will be forming plus 3. And the other ones which are not coming under the first 20 elements in the periodic table, they will be mostly forming plus 2, except for some. Okay, so here Fe2 plus will be formed by losing 2 electrons. When you lose 2 electrons, Fe2 plus will be formed. That means Fe is going to lose 2 electrons and form Fe2 plus. What is this? This is the oxidation half reaction. This is in the aqueous form. When the Fe oxidizes, this electrode will dissolve and it will come into the aqueous form. This will dissolve the electrode and it will form Fe2 plus in the aqueous state while releasing 2 electrons. Okay. So this is the oxidation half reaction. When we are writing this half reaction, you need to consider mainly 2 things. First of all, balancing. The atoms or the molecules which are in both the sides of this equation, they should be balanced. The same number of atoms and molecules should be there. Also the charges. The charges should also be balanced. So the first priority goes to the number of atoms. Atoms should be balanced, and then the charges should also be balanced. Now shall we check here whether the atoms are balanced and the charges are balanced here? So yes, there is only one Fe here. There is only one Fe here. Atoms are balanced. Done. And now when we consider the charges, here the charge is 0 because there are no ions. It is an atom, the charge is 0. Here it has plus 2 charge. And there is 2 electrons, right? 2 electrons are negative, which means 2 electrons means there is minus 2, which will both add up to 0. That means the charges are also balanced from the both sides. So whenever you are writing a half equation, you have to check whether the atoms and the charges are balanced. So yes, iron is going to oxidize here like this way. And then H plus is there to reduce. H plus is going to accept the electrons which are given by the iron. And then it will become reduced. So H plus is already in the aqueous form. Already it is in the aqueous form. And when it reduces, what will it become? So now the plus is going to become less positive. It has to become more negative. That means it can become, H plus becomes H2. There is no H, right? In native, naturally there is no atoms like H. They always form hydrogen gas, H2 gas. Therefore, they always form H2. Okay, so H2 gas, this is gas. So H plus is becoming H2. It has become less positive because this has plus 1 charge and this is 0. Okay, so that is done by gaining electrons. So it has to gain electrons. So first of all, so 1H plus will gain 1 electron. 1H plus will gain 1 electron. But here, when we balance the atoms, there will be 2H plus here because there are 2H here. We have to put 2H plus here. Whenever we balance, we are not going to put it in the subscript, okay? We always, when we balance, the number should be put as the coefficient, not the subscript. We cannot write it this way. This has come by the chemical formula, not by the balancing part. This is come by balancing. So yes, this is the coefficient should be put as the 2. So 2H plus becoming H2. For 1H plus, it should gain 1 electron. So yes, when we can also consider the charges here, because as there is plus 2 charge here by the 2H plus, there is only 1 minus. 1 minus, minus 1 by the electron. And here there is 0. There should be 2, right? There should be 2 minus to become 0. So therefore 2 electron. 2 electron. 2 electron will be there. So 2H plus will gain 2 electrons to become H2 gas. So this is the reduction half reaction. So what has happened here is iron will be losing electrons and that will be gained by the H plus to form H2. Okay, so we'll see what will happen here. The actual scenario that happens here is Fe will be oxidizing, and it will reduce. Gradually, this anode will be dissolving, and the Fe2 plus will be coming into this aqueous solution, and there will be also electrons here. So these electrons also will be there, which is released by the iron. Okay, and the H plus will also be there here now. So the H plus will be moving towards the cathode here. Okay, sorry. So the Fe2 plus is here. And the electrons which it releases goes through this wire. The electrons will be going through this wire and comes to the copper cathode. So as the electrons come here, H plus will be coming near the cathode to accept these electrons. So that's why reduction site is copper. That's why reduction site has become copper. Because the electrons will be moving through this wire and it will come here. And the H plus will be moving towards the cathode to accept those electrons, and then H2 gas will be released here. So H2 gas will be released near the copper cathode. Right? That's what taking place here. So there is an electron movement, right? Here, there is an electron movement. Electron, to produce an electricity, electrons will be always moving from which terminal to which terminal? Negative to positive. Electrons always move from negative to positive terminal. And the electricity by convention, it will be moving from positive to negative. So here, electrons is moving from iron to copper, which means iron is negative. Iron is negatively charged and the copper is positively charged. So from the negative terminal, electrons will be moving towards the copper, which is a positive terminal, and thereby, due to the electron movement, so when there is an electron movement or when there is an ion movement, electricity will be generated. So the electricity will be moving from copper like this way, okay, to the iron. So because there is an electricity generated, what will happen to this motor? The motor will work. You will be observing it. The motor will be working. You can observe it. And what are the observations? What are the other observations we can see? So yeah, the motor will be working. Or else if we, instead of motor, we can also use the instruments like ammeter, galvanometer, which shows the detection of electricity. Which detects electricity. Any other appliances which detects electricity can be used. We can even use a bulb here to check whether the electricity is there. So if there is electricity, the bulb will be working. It will be glowing, right? So in electrochemical cell, as electricity is produced, we can use any appliance which uses electricity to detect it, whether the electricity is produced. So here as motor is connected, motor will be working, right? And also other observations are this iron electrode, the anode, the strip will be dissolving, this wire will be dissolving gradually. If ammeter is used here, the ammeter pointer will deflect, which detects electricity. Also, another one is here the gas bubbles will be evolving. What are the gas bubbles evolving here? Hydrogen. hydrogen gas bubbles will be evolving near the cathode here, right? So those are the observations that we can get through this. So when we are considering, so this is an electrochemical cell. When we are dealing with electrochemical cell, first of all, you just need to know, you just need to write all the species present there. You need to classify them whether they can undergo oxidation and reduction. And then you have to choose the one which is undergoing oxidation or reduction. And then, yeah, just you can get the anode by it is a site which undergoes oxidation. And the anode will always be negative in an electrochemical cell. In an electrochemical cell, anode will always be negative and the cathode will always be positive. Right? So then electrons will be moving from the anode to the cathode. Okay, so this is how you deal with an electrochemical cell. All clear? All clear. You all can text me. All clear, right? Okay. So you all should have taken down all the points. That means the steps. Okay. So yes, first of all, how to approach an electrochemical cell. This is an electrochemical cell because there is no dry cell connected. That's it. Dry cell or any other source of electricity is not connected, but an appliance which is using electricity is connected. Therefore, this is an electrochemical cell. Okay. So So now imagine there were no, I mean, just I'm saying, there were no metals here, right? There were no metals like copper or iron were not present. So there's only OH minus and SO4 2 minus present here. So now you all need to identify whether which one will undergo oxidation now. So when we consider this in the activity series, we are not talking about these ions. So then how will you identify which one will undergo oxidation? Easy. The one which has the less number of atoms will undergo oxidation. Keep in mind. Whenever you are dealing with ions which are not present in this activity series, keep in mind that the ones which is which is easier to deal with, which means the ones which has a less number of atoms present, that will undergo oxidation or reduction. Okay, so here OH minus will be undergoing. If there is no any metals present here, I'm just saying for an example, right? Then I'll erase it now. And wait. So now they have asked name the parts labeled as X and Y now. So X is what? X is anode. And the Y is cathode. So yeah, I asked you to name X as the iron wire is X and the copper wire is Y. Right? So X is anode and Y is cathode. And then they have asked write an observation that can be made from the above experimental setup. So now I have talked everything about the apparatus B. Talked everything about all the observations. What are the observations? The small motor would be working. What else? The iron strip will be dissolving, that is, the anode will be dissolving, and the gas bubbles would be evolving. Those are the observations which you can see with your eye. When you do this experiment in your laboratory, you would be able to observe it. Okay. And now we to identify the observations which would be taking place in the apparatus A. Let's talk about that. So here they have connected like this. This is a positive terminal and this is a negative. And they have used pencil rods. What is made by, pencil rods are made by which element? It's carbon. That means they have used carbon graphite here. Carbon. This is also carbon. Graphite. Right? Pencil rods are made up of carbon. And yes, they have used the same electrolyte here. Same electrolyte, DH2SO4. So here, first of all, we need to identify whether this is an electrolytic cell. How did I identify that? Because here there is a dry cell connected, then there is an electrolytic cell. That means we are supplying electricity for a reaction to take place. On the other hand, in the electrochemical cell, electricity was produced, right, by a chemical reaction that was taking place within this. Electricity was produced, and it was going through this wire. But here we are providing electricity and we are making a chemical reaction to happen within this cell, right? So here also, first of all, we need to identify which are the, first of all, we can identify here which are the positive terminal and the negative terminal, easy. So the one which is connected to the positive terminal of the dry cell is positive, which means this is positive. And the one which is connected to the negative terminal of the dry cell is negative. Here they have used pencil rods, graphite rods, because they are inert. Mostly in the electrolytic cells, they will be using inert electrodes, mostly, okay? In the electrolytic cells, they will be inert. Inert means they don't undergo chemical reactions easily. That means those electrodes will not be participating in this process. So they will be using carbon graphite or they will be using platinum. Okay, so mostly the electrodes will not be participating mostly in electrolytic cell, not in all, but yeah, some, mostly. Right? So only the species present in the electrolyte will be participating in the process. So when we consider the electrolyte here, the same species will be produced. As carbon is not participating in this process, it is an inert one. We can only consider the species present in the electrolyte. So DIL H2SO4 means there is H plus, there is OH minus coming from water, and there is H2O4 2 minus. Now, among these three, we have to identify which will undergo oxidation and which will undergo reduction. Easy, same way, right? So H plus for oxidation, H plus cannot undergo oxidation because it is already positive. It does not like to become more positive. So OH minus and SO4 2 minus can undergo, it will like to undergo. And in the reduction part, the same thing, only H plus will be there and it will undergo reduction here too. Right? So from these two, which will undergo oxidation, it would be OH minus because it is easier to deal with. There's only 2 atoms, while here there are 6 atoms. Right? So yes, so the OH minus will be undergoing oxidation here. So we have identified the species which would undergo oxidation and reduction. Now we have to write the oxidation half reaction and the reduction half reaction. So reduction half reaction would be the same. H plus aqueous, 2H plus will be gaining 2 electrons to become H2 gas. On the other hand, OH minus, okay. When we're dealing with OH minus aqueous, when it undergoes oxidation, what will it produce? Actually, when it undergoes, this is something you need to memorize. Like memorize means you need to keep that in mind that OH minus, when it undergoes oxidation, it releases water and oxygen. Water and oxygen gas. Water liquid and oxygen gas. Okay, so now we need to balance these and also we need to balance the charges and all know by the gaining electrons. So this will gain electrons. Sorry, oxidation, it will lose electrons. It will lose electrons here. So to easily keep that in mind, I can suggest you a way here. An easy trick. You just need to know that there will be 4 OH minus participating in the reaction when it is oxidizing. There will be 4 OH minus participating in the reaction. Okay, and then write those OH minus here like this. The charges, write 4 OH. Okay. Now create the maximum possible amount of water and oxygen here, easy. So we can use one water from this. This is one water, H2O. And we can use another water we can produce. H2O. So there can be two water molecules produced. Two water molecules would be produced. So two oxygen atoms remain. So oxygen they always form O2. They don't exist as atom, right? They form O2 molecule. So one O2 molecule and two H2O will be formed. So easily balanced. Two H2O, one O2. Okay, as there is 4 negative charge here, minus 4 is present on this side. There is no other charge here. There will be 4 electron here too to balance the charges. Easy. Clear? Is that clear? You just have to remember that there will be 4 OH minus involving in the equation where it is oxidizing. Okay, then you just need to write 4 OH like this and you create the water, maximum possible amount of water. 1, 2. Two water can be created right there on the other side. And these two oxygen atoms will combine to form O2. And as your balance charges, as 4H minus is here, 4 electrons will be there. Right? So this is the oxidation half reaction taking place here. So whenever you are dealing with OH minus, you can use that trick. Okay, a small trick. Right? So yes, this is the reduction and this is the oxidation. So oxidation will be taking place at the anode and the reduction will be taking place at the cathode, right? That is a rule now. So yes, here, first of all, so this I have written the oxidation and reduction half reaction. But when we are dealing with realistically, when we are dealing with this cell, first of all, what you need to do is when you identify all the species present in the cell, then you need to, so all these species are present here in the aqueous solution, right? So you need to identify which species will move towards the positive terminal and which species will be moving towards the negative terminal in electrolytic cell. Because in an electrolytic cell, the first step is to identify the terminal. But in the electrochemical cell, only at the end we identify the terminals. So here, to the positive terminal, so the opposites attract. So towards the positive terminal, negative ions will be moving. That means SO4 2 minus and OH minus will be here. And H plus will be moving towards this negative terminal. So now you can say the place where the oxygen reduction taking place. Here, oxidation will be taking place here, and the reduction will be taking place here. Here, oxidation will be taking place, and the reduction will be taking place here because H plus is here and the OH minus is here. Right? So here, H2 gas will be produced. H2 gas will be produced near the negative terminal. So this will be the anode because oxidation is taking place here. And this will be the cathode because reduction is taking place here. So here H2 gas bubbles will be releasing near the cathode and water will be formed here and the oxygen gas will be releasing near the anode. Right? Oxygen gas will be releasing near the anode. So gas bubbles will be seen near both the cathode and the anode. So now you can identify that in the electrolytic cell, anode is positive and the cathode is negative. As the opposite of the electrochemical cell. In the electrochemical cell, anode will always be negative and the cathode will always be positive. But in the electrolytic cell, anode is positive and the cathode is negative. Right? So, as we can write the observations here too, saying that the gas bubbles will be releasing both near the anode and the cathode. Those are the two observations. Because the electrodes are not involving in the reaction, right? So only the gas bubbles release will be there. Right? So is that clear? All clear? Is everything clear? Good. Okay, then you all need me to write the overall ionic equation and the balanced chemical equation. We can write the overall ionic equation as well as the balanced chemical equation in both these cells actually. I can show an example here. So in the overall ionic equation means we have to combine both these equations to form the ionic equation. Okay, so in the ionic equation, what matters is that electrons cannot be present in the ionic equation. Only in the half reactions, electrons can be there. But when we are writing the overall ionic equation, then we have to cut these electrons. So how can we cut those electrons? First of all, we need to equate these electrons in both these equations. Like there is only 2 electrons here, but there are 4 electrons here. If we make this 4, we can cut this both because they are in the opposite sides. One is in the left side and the one is in the right side. So to make this 4, we can multiply the whole equation. When we are multiplying, we have to multiply the whole equation by 2. If you multiply it by 2, then it will be becoming 4E plus 4H plus equals producing 2H2 gas. Right? So by writing this, we can cut now. Okay, now if I erase this, I'll erase this whole part. So now to write the overall ionic equation, we need to write everything that is on the left side together, right? So yes, 4 electrons will be there. 4 electrons, right, coming from this. 4H plus the 4H minus from the other. On the right hand side, there are 2H2O, O2 gas plus 4 electrons. So now the electrons can get cut, right? Because they are in the same as the left hand side and the right hand side, so we can cut these two. So now there are no electrons. So yes, the main rule in writing the overall ionic equation is to cut the electrons. You can't include the electrons present in the half reaction. Right, wait. So now we can cut the electrons from both the sides. So now this is the overall ionic equation. This is named as the ionic equation because there are ions present. So so when we check the charge in the both side, here it is 0 because there are no ions. H2O is 0, O2 is 0. Here 4H plus will be giving plus 4 charge. 4OH minus will be giving minus 4, which also adds up to 0. So the charges are also balanced. Charges are also balanced. So this is the overall ionic equation. Overall ionic equation. Right? Now we can also write the balanced chemical equation. The next process. The next step is write the balanced chemical equation. To write the balanced chemical equation, the ions cannot be present in the balanced chemical equation. That means charged ions cannot be present, which is present in the ionic equation. They cannot be present in the balanced chemical equation. So what we have to do is we have to combine the positive ions and the negative ions together to form the compound. So the H plus and OH minus will combine together to form water, right? H plus and OH minus will combine together to form water. As there are 4H plus and 4H minus, here 2 water can be formed. Check here, 2 into 2, 4H. Sorry. 4 water can be formed. 4H plus will combine with 4OH minus to form 4 water molecules. So yes, now when we consider the oxygen, yeah, there are 4 oxygen. Here is also 4 oxygen. So 4H plus and 4H plus H minus here will combine to form 8H here. So that means 4 H2O molecules will be there. 4 H2O liquid. So I haven't written here the H2 gas, no? This side, I haven't written the H2. 2 H2O also there on this side. So now 4H2O liquid is forming 2H2O liquid plus O2 gas plus 2H2 gas. Now there is water molecules in both sides. Can we cut? Yes, we can cut. Left hand side and right hand side, there are same molecules, they can cut. So these two water molecules can be cut with these two, and the two will be remaining. Two water molecules will be remaining. So the final balanced chemical equation would be 2H2O liquid giving 1O2 gas plus 2H2 gas. This is the balanced chemical equation. Now we can check whether the atoms are balanced. Yes, two oxygen is there. Here is also two oxygen. 2 into 2, 4 hydrogen. Here is also 2 into 2, 4 hydrogen. So yes, this is the balanced chemical. Are there ions here? No. Ions, charges cannot be present in the balanced chemical equation. So this is how you can write a balanced chemical equation too. Right? All clear in that? All clear, right? Okay, now in the fourth question, they are asking, mention the energy conversion taking place in the above experiment. Mention the energy conversion. I've already said it. As the apparatus A is electrolytic cell, as the apparatus A is an electrolytic cell, and the dry cell is connected, electricity is being given. That means electric energy is being converted to chemical energy. Electricity is being given, and a chemical reaction is taking place within the cell. So electric energy is being converted to chemical energy there. You all can write it fully, right? I just wrote EE and CE. And in the apparatus B, it is in the opposite way. It is producing electricity by the chemical energy. So the chemical energy will be converted to electric energy in the apparatus B. Electric energy in the apparatus B. That is the energy conversion taking place. Right? So that's what happens in the electrochemical cell. Because the dry cell is not connected, electricity is being produced. And then in the fifth question, they are saying state the reason for the change in the mass of the electrode connected to the negative terminal of the multimeter. Here actually in this question, they have not connected a multimeter. But can you all guess if it is connected, a multimeter is connected. Multimeter means it can measure electricity or voltage. So there are many options in that, resistance and all. So if we just guess that if a multimeter is connected, to which apparatus will it be connected? It will be connected to apparatus A or B. Why is multimeter connected? To detect the electricity produced. So in which apparatus electricity is produced? It is in the apparatus B, in an electrochemical cell. So we can connect the multimeter to the electrochemical cell here in the apparatus B. So they are saying that mass of the electrode which is connected to the negative terminal of the multimeter, which is connected to the negative terminal, I said Fe. The ion is negative. Ion is negative, right? In the apparatus B, ion was negative because it is an electrochemical cell. Ion is the anode and it is negative. Copper is a cathode and it will be positive. So they are saying the mass is changing. Exactly, definitely the mass will be changing. Why will be the mass changing? Because it will dissolve to form Fe2 plus. So the reason is the ion electrode dissolves, leading to a decrease of the mass. So that's why there will be a decrease in the mass. So that's correct. So the reason is the ion will be dissolving to form Fe2 plus. So that means the anode, the electrode will be dissolving gradually and its mass will be reducing. Right? And then the final one, mention an industrial application of the above experiment. So electrochemical cells and electrolytic cells, they can be used for many purposes. They can be very useful. Okay, so here in the electrochemical cell is present in the car batteries and all. The car batteries, mostly the batteries, they are electrochemical cells. In the electrolytic cells, they are present. They are used for many purposes like electroplating. I'll be explaining what electroplating is. Electroplating is plating a metal on another object. We are plating it. We are coating it. So that is an electrolytic process. And also there is a thing called metal refining. Metal refining is purifying a metal. Purifying, we are taking a metal like copper can be taken, and if we do the electrolytic process using that copper, then we can purify that copper. And we can get the pure copper using that. That is metal refining. Right? And also the extraction of metals. In your syllabus, there is down cell. No, down cell is the sodium production. So sodium is a metal, so like that, extraction of metals can also be done using electrolysis. So down cell, using the down cell, sodium is produced, and there are others also, but they are not in the syllabus. And there's also a thing called NaOH production. NaOH production will be done using a cell called a diaphragm cell. Diaphragm cell. So these are all these applications of electrolytic cells. Most of the applications of electrolysis, electrochemical cells, they are only like the car batteries, the electrochemical cells, something like that. Only the batteries. Okay. So these are the applications of both the processes. Right. So that is the end of that question. So now in the what? Electrolytic cell, I didn't show the pathway of the electricity, no? So yes, this is electrolytic cell now. Yeah, I just show the pathway. So here, if I take this as positive and this is negative, electricity will be always moving from the positive terminal to negative now. So here the electricity will be coming down like this, like this, like this, and it will go through this, go through the solution. It will go through the solution and it has to move to the other electrode like this. Electrons will be moving like this, and opposite to that, the electricity will be moving from the positive terminal to the negative terminal. So now you can clearly identify that electricity is moving through the solution in electrolysis process. In the electrochemical process, it was not moving through the solution. It was moving only through the wire. Because in the electrochemical cell, it was like this, no? So if a motor is connected like this, then this is positive and negative. It will be moving like this. It can move like this. But here, it has to come through this and go to the solution and come to the other terminal. So therefore, electrolytes are very important electrolysis process. Electrolytes can only be used for this electrolysis because it should conduct electricity. So electrolytes should definitely be used. Non-electrolytes cannot be used. Examples of non-electrolytes are like distilled water. Distilled water is pure water, not the water which we drink also. So distilled water is a non-electrolyte, and other organic solvents like petrol, diesel, they cannot conduct electricity. So they cannot be used in electrolytic process because definitely the electricity should be moving through this to come here. So that's why electrolytes, electrolysis. That's why they are connected. Electrolytes, electrolysis. Okay, so the electricity will be moving through this solution. Therefore, it should be definitely be able to conduct electricity. But here we can also use a non-electrolyte if we want, because the electricity will be moving from the rods through the wire, not through the solution. right? So this is about how to deal with an electrochemical cell and electrolytic cell, right? So there are several other examples in your book. So now we don't have time to discuss all those, but there are several other examples given. So you just do this today. After the class finishes, you'll be having time now during the night. You all can just try all the electrolytic cells and electrochemical cells present in your book. Just try writing it, drawing that apparatus, and try writing all the oxidation, reduction, of reaction, and then check with the book. Then you will be able to deal with every type of electrochemical cell and electrolytic cell that is given in your exam paper. Okay, so that's how you deal with this. And now, wait, I'll drink some more. So if we have time, I can also explain another example for electrochemical or electrolytic cell, but yeah, we'll see. Okay, and now we'll go to the MCQ number 25. MCQ 25. Okay, it's a very easy question for the quantification lesson. Very easy one. So here, in the MCQ 25, they have given that of the following compounds, what is the compound in which the percentage of oxygen by mass is 50? 50%. Oxygen, mass of oxygen by mass should be 50%. And which compound is that? And they have given in the bracket, but what have they given? They have given the relative atomic masses. Relative atomic masses have been given. So relative atomic masses, they don't have units, okay? So I forgot to explain that because relative atomic mass means the mass of an atom, mass, like if I consider oxygen, mass of oxygen divided by mass of 112 into the mass of carbon, no? Carbon 612, no? So this is also mass, this is also mass. So if I take it as grams and this also in grams, the gram and gram will be cancelled. Therefore, the relative atomic mass or the relative molecular mass, they don't have units, right? They don't have units. So here they have not given the units. They have given the relative atomic masses of hydrogen as 1, carbon 12, nitrogen 14, oxygen 16, magnesium 24, and calcium 14. Okay, and they are asking about the mass of oxygen. 50% of oxygen should be present in that compound. Now, if we consider the compound 1, NH4OH, ammonium hydroxide, actually, this is ammonium hydroxide. Now, we have to take the total mass of this. How can we take it? They have given the relative atomic masses now, so we can find the relative molecular mass. Hydrogen 1, oxygen 16. There are 4 other hydrogen, therefore 4 into 1, 4 plus what else? Nitrogen. Nitrogen is 14. So nitrogen is 14. When we add up this, what is the answer? 16, 35, no? 16, 26, 30, 34, 35. Yes, 35. It's add up to 35. And now the oxygen mass in it is only 16, 35, 16. So is it 50%? So that means mass of oxygen divided by the total mass. Mass of oxygen divided by the total mass into 100 would give the percentage. Into 100 will give the percentage. So 16 over 35 is exactly not 50 now. It is not exactly 50. That means it should get cut into 2, no? 0.5 should be there, half. To become 50, it should be the half. So it is not half here. Right? And then, so then that is not the answer. In the second one, what have they given? Calcium hydroxide. They are given calcium hydroxide. So this is calcium hydroxide. How did you get this chemical formula? We can get this chemical formula easily like this. We have to first of all write the calcium positive ion. So this would be positive. Positive ion will always be given first. Negative ion will be next. So OH minus is the negative ion here. OH minus. So we have to write the valencies. We have to write the valencies and we have to interchange the valencies. So the valency is mostly equal to the charge which they form. Calcium's valency is +2. I mean, yeah, I'll explain it later. But yeah, calcium's valence is +2 because it is from the second group. Second group's calcium valence is +2. So this is +2. It forms +2 ions. And OH minus is valency, it is minus. That's why it became OH minus. We are not writing the charge here. We are writing it here. This is a valency, OH minus. And we can interchange it like this. When we interchange it, we need to ignore the signs. We need to ignore the signs. We are not considering the signs. So calcium and the 2 is common for both oxygen and hydrogen here. Therefore, we are putting a bracket here. So this is calcium hydroxide. That's why we are using a bracket here, calcium hydroxide. So this is how it is produced. So for this, there is a rule called the panic rule. You can use it if you are still struggling with chemical formula. Writing. Panic rule. Panic rule here, the first is positive ion first. First says positive ion first. That means always when you write, positive ion should be the first one. And here this is anion. Anion the second. Anion is negative. Anion comes second. And next one, N. N is, what is it? Wait, I use a phone. Numbers, numbers should be interchanged. Numbers should be interchanged. Numbers should be interchanged. And then I is ignore the charges. Ignore the charges. We don't consider the signs, the charges. And finally, cut. Cut if it can be simplified. Cut if it can be simplified. Which means if I say that, like, imagine calcium hydroxide's formula is like this, I get it like this. Just imagine like this. Then we can cut this because we can simplify this now. And the calcium hydroxide formula will be coming like this. So yeah, positive ion will always be first. First, the anion will be second. The numbers should be interchanged. They come from crisscross. And then ignore the charges. We don't consider the charges. We don't consider the positive charge or the negative charge. And then finally, cut if it can be simplified. That is a panic rule. So if you struggle with it, you can use this also. Right? So right, we consider the second one. It is calcium hydroxide. So the total mass we can find because the relative atomic masses are given. Calcium's relative atomic mass is given as 40. So here there is 2 oxygen, right? Because it comes under within the bracket. Okay, bracket is owned by both oxygen and hydrogen. So that the 2 is for both oxygen and hydrogen. So there are 2 oxygens here, which means 16 into 2. 16 into 2 plus hydrogen 1 into 2. Okay, that is equal to 40 plus 16 into 2 means 32 and 2. 4, 74. 74, no? 40. 72, 74. Yes, 74. So the total mass is 74 here. Oxygen's mass here is 32. 16 into 2, 32. That means it's exactly half. It is exactly half of the compound. No, 1, 2. 1 over 2 into 100 percentage, which means it is 50. Oh no, wait. 32, 64, no? Calcium 40. Yes, no. 32 and 32, 64. Okay, then this is all not. This is 74 and that is 32. 64 means it's half. It's 74, no? We'll check then. Did I go wrong anywhere? We'll check the third one. CH3OH. Carbon 12. There are 4 hydrogen, then 4 plus 1 oxygen. It is 16. 16, 26, 28, 28 and 32. This is okay. Okay, so this comes as wait. Yes. So the oxygen is 16 here. 16 over 32 into 100, that is 50%. Okay, then. So then CH3OH, so C is 12, H4, therefore 4, and oxygen is 16. So the total would be 32. And within that 32, oxygen is 16, which is exactly half. That means it has occupied a 50% of this mass. So the answer would be answer 3. So then we don't need to struggle about finding the answer number 4. Okay, so the answer would be answer 3. All clear, right? All clear? Is everything clear about it? Okay, good. Others? You will have any doubts? No, right? Okay. Then. Okay, then shall we take a break? We'll take a break of 10 minutes. Okay, we'll take a break of 10 minutes. So join by 5:10. 5:10. Is everyone here now? Are you all back? Shall we start? Shall we start then? Okay. So next, we'll go to the question number 19. Okay, MCQ 19. MCQ 19. MCQ 19, and they are they're talking about the electroplating process, which is an application of the electrolysis. Application of electrolysis. So the question says, which of the following statements is false about the electroplating of iron? So they have given some statements and they are asking which is false among these statements. So first of all, to answer this, we need to know what is electroplating, what is the process behind it, what is actually happening, and all. So here, when it comes to the electroplating, it is an industrial application that we use by the process electrolysis. Okay, electroplating is actually coating an object with a metal. Using a metal, we are coating another object. Like, for silver jewelry, they are applying gold, the gold color. They use a metal which has a gold color and they coat it. They coat with it, the silver jewelry or something. The other jewelries which we call some, say, like imitation and all, they have coated in like gold color, no, but they're not actually gold. So that is the process of electroplating. And also the doorknobs, which is in golden color. There are silver color doorknobs and all. The keys, they're all electroplated. Okay, and then nickel or chromium can also be applied on steel. So which means we are going to apply a thin metallic layer on a given surface using electrolysis. We are applying it using electrolysis, using the process electrolysis. Okay. So coating, for coating we are using a metal, and that metal should have a special property. If not, we don't have to coat. There should be something special in that metal so that we can coat it to any other object. So those special properties are like if it is resistance for rusting, if it is resistive for rusting, it does not undergo rusting. Or else if it has an attractive color, like the gold color, the silver color. Or else if it is inert, that means it does not undergo chemical reaction with others, with the surrounding materials. If it does not undergo a chemical reaction easily, then that is also a special property. Then we can use that metal with a special property and we can coat that metal onto the another object which we prefer. So that process is called electroplating. Right. So here, when we are using, we are doing it using this process called electrolysis now. So in electrolysis, there is an electrolyte used, there should be electrodes connected. So here, there are general rules for this process, for the electroplating. That is, the main rule is the object to be plated, the object that should be plated, that is kept as the cathode. That should be used as a cathode. Okay. And the plate or rod which is made of the metal, then that is used as the anode. The metal which you are using to plate. Any rod or a plate which is made up of that metal can be used as the anode. Right? So object should always be the cathode. Sorry. The metal should always be the anode metal. Right? And then we have to use an electrolyte which conducts electricity, right? We need to use an electrolyte for electrolysis. So the electrolyte should be a salt of the metal that is used for plating. That is a salt of this metal which is used for plating. A salt means anything that is connected. So metal will always form the positive ion, no? So any negative ion connected to that metal, then that forms a salt. Like if I'm using silver, then I can use silver chloride as a salt. So metal connected to any anion, that is a salt of that metal. OAG2SO4, that is silver sulfate. So if I'm using the silver as this metal to coat, then I can use this kind of electrolytes for that process. Okay, so any the electrolyte should be a salt of the metal. Salt of the metal. So that is a liquid or a solution which should be a salt. Okay, so these electrolytes, so they should be able to conduct electricity and all. So therefore, ionic compounds can be used. So yeah, as it is a salt, it should be an ionic compound. Covalent compounds cannot be used as an electrolyte. Okay, and then so if we consider the process about what is happening here, let me draw the cell. So yes, if I draw the cell like this is a cell, and here I have used an electrolyte, and this is a rod which I have used. This is the object which I have to plate. Imagine this is a iron spoon. I have to plate an iron spoon. Okay, so iron spoon. So here, iron spoon should be the cathode. Iron spoon should be the cathode because this is the object to be plated. So this is the cathode. And this is the anode, right? This is the anode, the metal which I'm using. So the metal which I'm using is copper. Imagine this is a copper rod I'm using. Okay, so the electrolyte which is used should be a salt of this copper. So I am using copper sulfate as electrolyte, CuSO4. Copper sulfate, we are ignoring the charges. The charge is equal to the valency. Okay, usually the charge which the ion forms, that is equal to the valency. Remember that. So this is SO4 2 minus. No, that minus 2 should be written here. Copper forms plus 2 ions, then its valence is plus 2. Then we are ignoring the charges. We are ignoring the charges. Numbers from crisscross. Then copper 2, sulfate 2. But here this can be cut. So therefore copper sulfate CuSO4. So the numbers can be simplified, therefore we cut it, and therefore copper sulfate is CuSO4. Okay. So this is CuSO4. I have used this as electrolyte, and I have so this is an electrolytic process. So therefore I should connect it to a dry cell. That means we need to provide electricity to this process. And so I'm connecting it to a dry cell. And we need to consider, we need to be careful about the terminals which we have connected here. As you know, the cathode in an electrolytic cell is always negative. The cathode in an electrolytic cell is always negative. So therefore it should connect it to the negative terminal. And the anode in an electrolytic cell is always positive, and therefore this is the anode, as I've already said. Then this should be positive, means it should be connected to the positive terminal. So then as it is connected to positive, this will be positive, and as this is connected to negative, this would be negative. Right? So here the electrolyte is used, CuSO4. So now we need to understand the process that is happening. So we have already marked the terminals, we have already marked the signs here. The anode and the cathode also known here now. And now we have to find all the species present here. We have to write all the species. So yeah, here the electrodes will be participating because they are reactive. So here copper is there, iron will be there. And here from copper sulfate, there will be copper 2 plus ions formed within this solution, and SO4 2 minus ion also will be formed. So therefore there will be Cu2 plus and SO4 2 minus. So this is not diluted, therefore there is no water. Okay, so therefore there is no H plus OH minus. So I have written all the species present here. Right. So now in an electrolytic cell, as we have already marked the terminals, we have to see which ions will move towards the positive terminal, which ions will move towards, which species will move towards the negative. So Cu2 plus will be moving towards the negative, right? Cu2 plus here. SO4 2 minus will come here. Right. So Cu2 plus will be moving towards the negative because this is positive and negative, opposite attracts, and here the negative will be moving towards the positive. That's all done. Okay. Now oxidation. Which will undergo oxidation. As I have already said, metal should always given the first priority for oxidation because they always like to lose electrons and form positive ions. So copper or Fe can undergo oxidation. Other than that, Cu2 plus cannot undergo because it is already positive. So then we are using a negative. So SO4 2 minus can also undergo oxidation. Right? So among these, which species will actually undergo oxidation? Not this, because metals are always given the first priority. Among these two metals, which is higher in the activity series, that will undergo oxidation. So copper and iron. Copper and iron. Iron is above. So therefore, iron will undergo oxidation. So wait. So iron score is corrected. Iron is negative, no? Iron spoon cathode. Cathode is negative. Copper or D is positive. So SO for 2 minus iron is there. OH minus is there. Copper is also there. In this column. Copper Fe oxidation. Metal oxidation will be more feasible. Wait. So for oxidation, there is so iron is here. Iron is already iron is negative here. So within this, there is SO for 2 minus and copper 2 plus. So for oxidation, oxidation should always take place at the anode. Oxidation should always take place at the anode means this cannot undergo, this cannot be taken as a species for oxidation, negative. Right, so copper is there and SO for 2 minus will be there. Copper and SO for 2 minus will be there. On the other hand, for reduction here, copper 2 plus will be able to reduce because this is positive and it can become more negative. So copper 2 plus is there, right, within here. Right, and Fe will not, it does not like to become reduced now because it is a metal. So it is not included in the reduction list. Okay, so copper here, so this can be cut because copper is given the highest priority. So copper will be oxidizing. So when the copper is oxidizing, copper will form copper 2 plus ions, copper aqueous. So I didn't use Fe here because Fe is negative, it is cathode. And it cannot undergo oxidation because it is the place where it undergoes reduction of. So here this is the place it undergoes oxidation. So copper 2 copper aqueous will undergo oxidation and form copper 2 plus aqueous by losing 2 electrons. By losing 2 electrons. So we cannot compare here because there is no iron. There is only copper, there is only one metal, so therefore it can undergo copper 2 plus aqueous, and it will become positive, right? And then, so therefore, this anode, it is undergoing oxidation and forming Cu2 plus ions, and that Cu2 plus ions will be moving towards the aqueous solution. Cu2 plus will be coming here. Okay. So the anode will be dissolving gradually. That is an observation. Anode will be dissolving gradually, like that will be dissolving. That can be observed by our naked eye. And now if we consider the reduction process, there is only Cu2 plus here. There is only Cu2 plus. Right? So if there is only Cu2 plus, it will undergo reduction because it is already positive and it likes to undergo reduction. So what happens is Cu2 plus reduces on the other hand. Cu2 plus aqueous will reduce to form its metal, copper. Copper solid will be formed. So it reduces by gaining the 2 electrons. Right? This is the oxidation process. And these electrons will be accepted by the Cu2 plus ions here, and it will undergo reduction to form copper. So copper will be formed here because the reduction is taking place here. The reduction is taking place here, and the Cu2 plus ions are moving here. So that means the iron spoon will be coated with copper. Wait a minute. Give me a minute. There's a call. So the cathodic reaction is Cu2 plus is there, and the Cu2 plus will be reacting here, and it will be getting reduced, and it forms copper solid here near the cathode, and therefore the cathode, which is the iron spoon, will be coated with the copper. That will be coated with the copper. That's how the iron spoon will be coated. That is what we call the electroplating process. We are using a metal to plate the object. Okay. So here, imagine there is water also, it is DCuSO4, which is mixed with water, okay? So there is H plus and OH minus 2. So however, OH minus will not undergo oxidation because here the priority will be given to the metal. And there will be H plus, no. H plus and Cu2 plus will be competing to become reduced. But here, when we consider in the activity series, H plus is here, the H is here, copper is here. The one which is below likes to reduce more. It has a greater tendency to reduce. Therefore, H plus will not reduce. So, however, copper 2 plus will be reducing because the one that is below has a greater tendency to reduce, and the one that is above will have the greater tendency to oxidize. So, that is the process that is taking place in this electroplating. Okay, so the rules in electroplating is that the cathode should always be the object, and the anode should always be the metal which we use. If it's the other way around, then you will be losing that iron spoon because the iron spoon will be dissolving as the anode. It will be dissolving. So there's no electroplating would be taking place. Just the iron spoon will be dissolving because it will form Fe2 plus. Okay, that's not our purpose here, right? So when we consider the question, they have given 4 statements. So the first statement says an aqueous solution of a compound of the metal that is electroplated should be the electrolyte. Correct, right? An aqueous solution of a compound of the metal that is electroplated. Salt of the metal should be used as electrolyte. So first statement would be correct. When we consider the second statement, electrolyte should be in high concentration for quality electroplating. That is wrong. Actually, the electrolyte should have a less concentration. Do you know why? The concentration will be affecting the rate of the reaction. So when there is a high concentration, the rate of the reaction will be high, no? That means the electroplating would be taking place faster, but that would not be more efficient, right? So it will not taking place like in the correct proper way. It will just take place faster, and it will not be coated in the right way. Okay, so if we make it the rate of the reaction is a lesser value, if the rate of the reaction is less, then it will be taking place slowly and nicely. It will be coated fully. So therefore, when we have a less concentration of electrolyte, the rate of reaction will be less. So the answer 2 would be false. The electrolyte should be high concentration is false. For quality electroplating, that is wrong. And when we consider the third one, iron should be made the cathode. As here they are talking about electroplating of iron. Iron should be made the cathode means they are true. The object that we are electroplating, that should be the cathode. That is right. And the current should be a direct, of course. We are not using alternative current for the electrolysis, okay? the alternative current means the positive and the negative sides will be changing. That means the anode and the cathode will be changing. That shouldn't happen, right? The anode and the cathode should be fixed. So therefore, a direct current should be there. That means the current should be moving only in one direction. So that is right. So the answer 2 is the false one. Okay. All clear with that? Is everything clear with the electrolysis and electroplating? Okay, right? Okay. Okay then. So now, so I just discussed MCQ 19, no? MCQ 34. Shall we go for a quantification question MCQ 34? MCQ 34. The MCQ 34, that is a quantification question. So here, given in the figure are masses of 4 gaseous hydrocarbons. What are hydrocarbons? Hydrocarbons means the compounds which contain only carbon and hydrogen. Those are hydrocarbons. So there are masses of 4 gaseous hydrocarbons given, in which of them equal number of molecules are contained. They are asking in which of these hydrocarbons equal number of molecules are seen. So in A, there is CH4, 8 grams. In B, there is C2H4, that is 7 grams. In C, there is also again C2H6, that is 10 grams given. And for the D, C3H8, 11 grams. This is MCQ 34. MCQ 34. So C3H8, 11 grams. Okay. So they are asking in which of these combinations equal number of molecules are found. So here they have given the relative atomic masses in the bracket. So yes, equal number of molecules. So the relative atomic masses are given, carbon is 12 and hydrogen is 1. So as we know, they have given the mass and we can find the relative molecular mass through this, and we can also find the molar mass. What is molar mass? Molar mass is the mass of 1 mole of that particular compound. Mass of 1 mole of that particular compound. So a scientist named Avogadro, what he did was, he found that when we take a compound which is equal to its relative molecular mass, or if it is an atom, if it is equal to the relative atomic mass, if we taken the mass in grams, then that would contain 1 mole of atoms or 1 mole of molecules would be there. For example, if I take CH4, CH4's relative molecular mass is 12 plus 4 into 1, which is 12 plus 4, 16. 16. So if I take these 16 grams, if I take 16 grams, imagine if I'm taking it in grams, okay, 16 grams of CH4, then there is this number of molecules. 6.022 into 10 to the power 24. 6.022 into 10 to the power 24 number of molecules will be there. Right? So this was found by the scientist Avogadro. So what he said was, if you take the mass of a compound or an atom in grams, I mean the relative atomic mass or the relative molecular mass should be taken in grams, then there will be this number of atoms or molecules found. So if I take hydrogen, hydrogen's relative atomic mass is 1 no. So if I take 1 gram of hydrogen, there will be this number of hydrogen atoms in that. Okay, then this is called 1 mole. This amount is called 1 mole. Okay, so here, so that means when we take the relative atomic mass or relative molecular mass in grams, that would be equal to the molar mass. This is equal to the molar mass. 16 grams. If we are taking it in grams, then that is equal to the molar mass. Easy. Because there is only 1 mole here. This is called 1 mole. Okay. So here if I consider the CH4 atom, so I have said that CH4's relative molecular mass is 16. 16. Then in 16 grams of CH4, there will be 1 mole. But here there is only 8. 1 mole means 6.022 into 10 to the power 23 CH4 molecules. But here there is only 8 grams. That means half of this. Then that means half moles. 0.5 mole would be there. The number of molecules should be divided by 2. Okay, so something like that. So if I use this equation also can be used. Number of moles is equal to mass over molar mass. We can find the number of moles by using this equation, mass over molar mass. Okay, mass is given. Molar mass can be found by the relative atomic mass or the relative molecular mass. So the number of moles of CH4 is equal to mass 8 grams. Molar mass, that is here the relative molecular mass is equal to 16, means the molar mass is 16 grams per mole. 16 grams per mole, which is equal to 0.5 mole. Then there is number of moles is 0.5, 1 over 2. Okay, now if we consider the C2H4, then there is 7 grams. So then 7 grams divided by the molar mass can be found by using the relative atomic masses. So here there are 12, 20, 24. 24 plus 4, 28. 28. So 7 divided by 28. 7 grams divided by 28 grams per mole, that will be giving the mole, number of moles. So that is 1 over 4, right? 1 over 4, if I simplify it. 7 into 4, 28. So 1 over 4, which is 0.25 moles. Which is 0.25 moles. Okay, so this is 0.5, this is 0.25, and when I consider the C2H6, when I consider the C2H6 molecule, we can also find the number of moles. N equal 10 grams are there, and if I divide it by the molar mass can be found using the relative atomic masses. So here there is 6 hydrogen, 2 carbon, 24, 24 and 6, 30. So 10 by 30, 1 over 3. 1 over 3. So we can simplify it. I simplify 1 over 3, what is the answer? Yeah, like 0.333 or something, 0.33, no? This number of moles will be there. Now the last one, 11 grams are there, and this is C3H8. So C3 means 12 into 3. 12 into 3 is 12, 24, 36. 36 plus 8, 44. 44. So this the relative molecular mass of C3H8 is 44. That means 44 grams is the molar mass. 44 grams is the molar mass. So 44 grams per mole. So I can cut this 1 over 4. That is also 0.25 mole. So here, what are the two molecules which have equal number of molecules? That is C2H4 and C3H8. C2H4 and C3H8. That is B and D. B and D, no? If I'm not wrong here. So yes, that's how we find it. So that's it. Go home and check these again, try these again, and you can find if I have made any mistakes also. So now finally in the electrochemistry part, we have one important discussion about the corrosion or the rusting. Corrosion or the rusting. So to study about that, we can go to a question here. Wait. MCQ 9. Yes. MCQ 9, that is about the corrosion or the rusting. For the MCQ 9, so here in MCQ 9, they have given 4 arrangements. Arrangements A, B, C, and D, which are set up by a student in the laboratory using 4 clean iron nails. So they have used iron nails to study about the corrosion of iron. So in the apparatus A, they have immersed the iron nail in seawater. They have immersed it in seawater. In B, they have immersed it in vinegar. And C and D are a type of cell. What is that type of cell? It is kind of an electrochemical cell, no? Electrochemical cell because there is no dry cell connected. So they have not connected appliance to detect the electricity also. But that's fine. We connect the appliance to detect the electricity. Even if we detect it or not, electricity will be flowing. So here they have not connected anything to detect the electricity, but yeah. So this is kind of an electrochemical cell because there is no dry cell connected. So the C and D. So in C they have used zinc plate and in the D they have used copper plate. Okay, so and the question they ask is, when observed after a few days, the nail in which the arrangement has corroded the least. That means they are asking in which nail we can find the least amount of corrosion. Okay, so first of all, what is corrosion? And what is taking place in corrosion? And what is rusting? So when we consider the corrosion means the changing of metals. That means the metals are subjected to changes when they are exposed to air. When you are exposing a metal to air, it will subject it to some changes. They are not some positive changes, right? They are negative. Like, tarnishing will take place. Tarnishing is like the color will fade. The metals, they have lustrous nature. They are shiny. That will fade. Okay, and then the surface will be deterred. The color change can be observed after some days if you're exposing it to air. That is corrosion. This takes place in metals. So specifically the corrosion of iron or steel. The corrosion of iron or steel can also be called as rusting. We can also call the corrosion of iron or steel as rusting. Rusting. So here in the question they have given iron now. So they have used iron nail. So I can also say that as rusting without saying corrosion. So they are asking in which setup we can find the amount of rusting, the least amount. Right? So they have said that these metals they are subjected to changes only when they are exposed to air. Why is it? They are subjected to changes only when they are exposed to air. Why is it? Because the factors which is needed for corrosion or rusting are found in the air. What are the factors which are needed for corrosion or rusting? They are water and oxygen. If there is water and oxygen gas found, then the rusting or corrosion would be taking place there. So these two are found in the air. No oxygen gas will be there, and water vapor will also be there. So therefore, when metals are exposed to the air, then it will be in contact with these substances, with these factors which are needed for rusting, and therefore they will get rusted or they will get corroded. Okay, so actually what is happening here is type of an electrochemical reaction would be taking place in this rusting process. So what is happening is iron is, when iron is rusting, what happens is iron will oxidize like it usually does. What it does is iron will be oxidized if we 2 plus aqueous plus 2 electron like this, it will be oxidized. And the water and the oxygen which are needed for this corrosion, they will be joining together to form OH minus ions. You know the opposite of what I taught earlier, like the OH minus when it gets oxidized, it will become water and oxygen. Now the water and oxygen they combine together and they reduce to form OH minus ions. So that will take place in rusting. So like this 2H2O plus O2 gas 4E producing 4OH minus aqueous. So this reaction will be taking place. So we can easily remember this like I have said before, the same thing. So you don't need to memorize it. If you remember that only 4H minus 4OH minus are involved here, you can do it this way. You can find this like this. Two water molecules will be there, then one oxygen molecule will be formed. And then you can balance the charges by adding 4 electrons. So that is taken place at the opposite side here in rusting. As this reaction is taking place only, we are saying that water and oxygen is needed definitely for rusting. Okay, so this is the oxidation half reaction and this is the reduction half reaction. And what happens is these two, after the process, if we write the overall ionic equation, if we write the overall ionic equation as there are 4 electrons here, we need to multiply this whole equation by 2 to equate the electrons. This will also become 4 now, this should also become 4. So then we can cut. So I am multiplying this like this. So then there would be 2Fe, 2 plus, and there would be 4 electrons. So now when I write the balanced ionic equation, so then whatever that is there in this left hand side, I can combine this together and write, and whatever there is in the right hand side, I can combine them together and write. Okay, so 2Fe plus 2H2O will be combining to form and O2 will be combining to form 2Fe2 plus 4OH minus. Okay, so that is the ionic equation. Because there are ions, there cannot be electrons. Ionic equation would be this. Okay, 2Fe plus 2H2, 2Fe plus 2H2O plus O2 will be forming 2Fe2 plus and 4OH minus ions. So to write the balanced chemical equation, I can combine the particular positive and the negative ions to form the compound. So what happens is these Fe2 plus and these OH minus ions, they combine. They combine together to form FeOH2. They combine together to form FeOH2. So the FeOH2, there can be two FeOH2 formed because there are two Fe and four OH. So Fe2 plus Fe2 2 equal OH minus 4. So yeah, 2 into 2 4. OH minus will also be balanced. So 2 ferrous hydroxide can be formed here. Okay, so this will be formed in the rusting process. And then this will also react with more oxygen in air. This will also react with more oxygen in air to form a compound called hydrated ferric oxide. It will form a compound called hydrated ferric oxide. That means, this is called as, we can also call this as hematite when it is alone. The ion extraction process as hematite, no, that is this. Fe2O3, right? Yes, yeah. So yes, it is ferric oxide and H2O. So hydrated ferric oxide will be formed. That means this will combine with the water molecules. This means we put a dot here because they are not reacting together, but they are combining together like to form a complex. So that is, this is called the hydrated ferric oxide, and this is what gives the reddish brown color for the rusting. Hydrated ferric oxide, this is what, this is actually the rust, which is foam, which is in the reddish brown color. That is Fe2O3 H2O. Okay, so this is the process that will be taking place in rusting. Okay, and we can also write the balanced chemical equation like this way. When this ferric oxide is formed, 4FeOH2 will be reacting with O2 gas to produce 2 hydrated ferric oxide plus 2 water molecule. This is given in your book, but this is something you need to remember. I mean, it is hard for you all to balance this. So you can remember this balanced chemical equation. You have to memorize this. So if you know the compounds, you just have to remember the coefficient. Okay, so this is what takes place, and this is the rust formed. Actually, many number of water can be combined with this, not only one. Many number can be combined. Therefore, we can also write it this way. XH2O. That is, X is a variable. That means the amount of water molecules combined can be varied. Okay, so this is called the rust. So this is what taking place in the rusting process. That means the electrochemical process is taking place here. Okay, so now, so that means you know that now for the rusting to take place, iron should oxidize, and the water and oxygen, they should reduce. So in the question they have given, in the apparatus 1, they have given seawater. No? Seawater mainly contains salts, right? They contain salts. Mainly sodium chloride will also be there. Mainly sodium chloride will be there. So you just need to know that the salts, they accelerate rusting. They speed up the rusting process. They make it even worse, the salts. So when you are using an ordinary cold water, and when you are using a water which is mixed with salt, the one which is mixed with salt will be rusted more. That means many salts, they accelerate rusting. That is why it is not much favorable to build houses near the coastal areas, because your equipments, your instruments, and everything that you use at your home, they will be corroded easily. They will be rusted easily because the breeze, it will be salty air now there. So therefore, it is not much favorable because they accelerate rusting. Okay, so here the apparatus A cannot be the answer because they are asking what is the least formed one. And the apparatus B, they have given vinegar. Vinegar is acidic, right? Because in vinegar, the main acid found in vinegar is acetic acid, CH3COOH, which is a weak acid. So acids also accelerate rusting. Acids also accelerate rusting. That is also something you need to remember. And the bases, they decelerate rusting. Bases, they decrease the speed, while the acids, they increase the speed of rusting. So as vinegar is used here, it will, because it contains this acetic acid and it is acidic, it will be rusted more. So B also cannot be the answer. If a base is used, then the speed would be less. Okay, and then in the third one, they have connected the iron nail. They have connected the iron nail to a zinc plate. In the third one, they have connected the iron nail to a zinc plate. They have used a zinc plate here. And they have used distilled water, no, here? They have used distilled water. Okay, so what happens here is, so there is iron, there is zinc, and there is water here. Oxygen will also be there. So the rusting will, however, take place. But there is zinc here, iron here, which will undergo oxidation when we consider zinc and iron. It is an electrochemical cell. They are competing for oxidation. Only one of them can undergo oxidation. So zinc and iron is there as metals. Metals are given the first priority for oxidation. So zinc is here. Iron is here. So zinc is above iron, which means which will undergo oxidation. Zinc will undergo oxidation. Zinc will undergo oxidation to form zinc 2 plus. So zinc is above iron, yeah. So it will undergo oxidation. So then iron will not undergo oxidation. That means rusting cannot take place here. Rusting cannot take place here. Now consider the fourth example that they have given, fourth apparatus that they have given. In that they have connected it to a copper plate. They have connected it to a copper plate. So here there is copper and there is iron. So the copper is below iron. No, copper is below iron in the activity series. That means iron has a greater tendency to oxidize than copper. So here rusting can take place more because this will become Fe2 plus. Here that will not take place. Okay, so here we can protect the iron from rusting by connecting it to a metal which is above it in the activity series. Any metal can be used above iron to protect the iron from rusting. This process is called the cathodic protection of iron. So as here the zinc is the anode. Zinc is the anode because it undergoes oxidation. This becomes a cathode. Okay, this becomes a cathode. Here in this process, here the water and oxygen, they will undergo reduction to form OH minus, and all this process will be taking place near the cathode. So here we are making iron as a cathode to protect it from rusting. That's why it is called cathodic protection of iron. But here we can't do that because iron will be the anode and the copper will become the cathode. We can also say that sacrificial protection because zinc is sacrificing itself to protect iron. So that is called the sacrificial protection too. So just remember that whenever we are connecting a metal that is above iron in the activity series to it, the rusting can be minimized. We can protect the iron or steel or any other metal from rusting. So here, as we are using metal iron, we have to use a metal that is above iron in the activity series. So when they asked after a few days, the nail in which the arrangement has corroded least is definitely would be C. It would be C. Okay. This is called the cathodic protection. We use this in several areas. You know, this is called the galvanizing. There is something called galvanizing, which means galvanizing is they coat zinc on the iron objects, like the buckets and all. If it is made up of iron, when it is made up of iron, these buckets and all, they will coat it with zinc so that they can protect it from rusting. That is called the galvanizing process. Even in the ships, ships is always they are in contact with the sea water now. It is always contact with the salty water. That means the rusting probability is very high. So what they do is they coat the hulls of the ships. That means which is in contact with the sea water with something metal that is above iron, like the magnesium, zinc, so that they can protect that part from rusting easily. Okay, so these are some applications which can be used by this cathodic protection of iron. So this is what's taking place in rusting. And you know what? This can they can also ask this in some other ways, like now I'll take the same example. So here the iron nail will be connected to zinc, okay? In the other one, iron nail will be connected to copper. Iron nail will be connected to copper. So now what this is in your exams, they can ask this like this also. So here they are using, if we use phenolphthalein, if we use phenolphthalein indicator, what is, it is an indicator, right? It changes colors with acids and bases. Okay, so the phenolphthalein color with acid is colorless. It does not show any color, colorless. But when phenolphthalein is in contact with some base, it will show a pink color. it will show pink color. Okay, so imagine they use some drops of phenolphthalein into this cell as well as this cell. Okay, so there is phenolphthalein in this cell as well as this cell. Now, here in this cell, in both the cells, the phenolphthalein will turn into pink because OH minus is produced. No, however, the water and oxygen, they will combine to produce OH minus. No, they reduce to form OH minus. So as there is OH minus, the phenolphthalein will change color because this is basic OH minus. H plus is acidic. So it will change color to pink, but the place where it changes color is different. Here, zinc is the anode. So here, in the cathode, at the cathode only this reaction will take place. So here, there will be a pink color near the iron. But here, iron will be oxidizing and the copper will be, here the reduction process will be taking place near the copper electrode. So therefore, the pink color will be here, formed here. So there will be these differences can be observed if we use phenolphthalein. And also they can use something, another indicator called, the potassium ferricyanide. You don't need to know the chemical formula of it, but you need to know the name. Potassium ferricyanide. So this is exclusively used to detect Fe2 plus ions only. It is used to detect Fe2 plus ions. That means if there is Fe2 plus ions, this will turn to blue color. This will show blue color. Potassium ferricyanide. So if we put some potassium ferricyanide into this cell, will it be formed? No. The blue color will not be formed because Fe2 plus is not formed here. Zinc is oxidizing. But when we put the potassium ferricyanide to this solution, we can see a blue color near this. Because Fe2 plus ions are formed here. Here rusting takes place, here rusting does not take place. So yeah, potassium ferricyanide can be used to detect Fe2 plus ions. So if we use potassium ferricyanide and if it changes color, that means rusting has taken place there. Okay, so in both these solutions, OH minus ions will be formed, but the places where they form will be different according to the anode and the cathode. Okay, so this is about rusting. So the arrangement which has corroded leaves would be the arrangement C. Clear then? All clear about corrosion, rusting? Okay, right? Okay. The same concept is used in the MCQ. Wait, let me see. MCQ 37. In the MCQ 37, it is also based on the corrosion of iron. So the corrosion of iron can be controlled by keeping iron in contact with the bivalent metal M. Bivalent metal M means that is forming 2 plus. This is bivalent. If its valence is plus 2, we can say it as bivalent. Okay, so they have said that corrosion of iron can be controlled by keeping iron in contact with the bivalent metal M. Yes, it can be done if it is above iron in the activity series. Yes. So now, what is the half reaction to which the metal M is subjected here? So they are asking what is the half reaction M is subjected. Like I used zinc before. If zinc is there, Fe will not become Fe2 plus, zinc will become zinc 2 plus by releasing 2 electrons. So that is what they are asking, saying it as the metal M. They use it as M. Okay, so the half reaction, the metal M is subjected here is oxidation half reaction. So that is the answer would be the first answer. Because the M solid will be forming M2 plus aqueous by releasing 2 electrons. Okay, so that comes under the same concept, right? So yes, that's about electrochemistry. And then now I have, we will just study about the periodic table. I'll just revise something about the periodic table and we have some other activity too. So yes, can you all draw the periodic table with me? We'll draw the periodic table. So for your periodic table, you have only, you have to only study about 20 elements now. So thank God, there are so much of elements present in the periodic table, but in your syllabus, you will have to only focus on first 20 elements. Okay, so here, please draw with me. Take a separate page, draw with me, complete this with me. Okay, so yeah, as we know in the periodic table, there are 8 groups, there are 8 columns. Okay, so I can draw it like this. Okay. So there are 8 columns will be there. That is, they are the 8 groups, and also there will be 4 rows, which are called the periods. Okay. So this is one period. This is the second period. This is the third period. And this is the fourth period. So when we usually mark the groups, we mark it using, we name it using the Roman numbers, like this: 1, 2, 3, 4, 5, 6, 7, and 8. And when we name the periods, we use it using the, we name it using the Hindu-Arabic numbers. That means the numbers we use normally. 1, 2, 3, 4. Okay, so there are 4 periods and there are 4 groups. So now we have to fill this grid. So when we fill this, we can use, wait, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now if we, when we fill this grid, we can use mnemonics to remember the order also. The ones which I remember is, it's a bit funny and it's in Tamil too, so don't mind. So how I remember is hi, hello, Lily, BBC News on Friday, நீயும் நானும் மக்கு அல்ல சின்ன பொண்ணு சமந்தா குளிக்க ஆர்யா கனவு காண. Okay, so this is how I then we can fill it using these kinds of mnemonics because so then it is easy for us to remember. So there are 20 elements here. So you have to study about these 20 elements. And then so here we can, there are metalloids, there are non-metals as well as there are metals. So the metalloids are the ones, here is boron and silicon. So we can draw a step here, a stair, like a staircase, we can write it. So use a color pen or a color pencil and draw a step here, like this. This is a step, a staircase, some kind of staircase. So, and the ones, the elements which are on the step, they are metalloids, which is meant by, what is meant by the metalloids? Because they have both the metallic characters as well as the non-metallic characters. They are metalloids. So you can color this boron and silicon using one color. You can use any color and color this boron and silicon using that because they are metalloids. So anything that is on the left side of this staircase are metals except hydrogen. Hydrogen is a gas and it is a non-metal. Except hydrogen, all the other ones that is left of this staircase, they are metals. Okay, and the ones which are on the right of this staircase, all of them, they are non-metals. All of these are non-metals. And among them, the group 8 elements, they are noble gases. They are noble gases. So you can color the noble gases in a different color. Noble gases are nonmetals too, but can use a different color for that. And the nonmetals as in one color, other nonmetals in one color, and metals in one color, and metalloids in another color. Okay? So these are the noble gases, which means they do not like to form bonds. Noble gases, they never like to form bonds because they are very stable, they are very independent, they are happy with themselves. They don't need any others to become stable. They are already stable. So those kind of ones are called noble gases. These are the noble gases. Helium, neon, argon. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So these are the noble gases, right? So we can also write the valency in a nice pattern. We can write the valency too above the groups. So this is how the valency changes according to the group. The valency of the group 1 is +1. This is +2, +3. The group 4 can become +4 or -4. This is, and then the sign changes to negative. So -3, -2, -1, 0. What is valency? Valency is a combining ability of an atom. How much it shows interest in combining with others. So the noble gases, they never show interest in combining with others because they are already filled nicely. So therefore, their valency is 0. They don't show any interest. And these ones, the +1, +2, +3, all these +1s, they likes to lose electrons. That's why they are forming plus. They like to lose electrons and form positive. So as I said before, metals, they always like to form plus ions. They always like to oxidize. That's why the metals here, except hydrogen, metals here, all of the metals here, they form +3 or +2 or +1, positive. Hydrogen is not a metal, but it shows +1, and it is in the first group because it has the chemical properties of hydrogen, and these metals, they are some kind of similar. So therefore, they have included in the first group, but it is a nonmetal. And when you consider the other nonmetals here, they form -3, -2, -1. That means they are gaining electrons, and they like to gain electrons and form negative. So these are the valencies. And the fourth group, they can form either +4 or -4 whenever, that is according to the situation. When they are combining with a negative one, they will form +4. When they are combining with a positive one, they will form -4. So they are adapters. Okay, so the fourth group people, they are adapters. Okay, so this is how the valency changes. So now you know, that's why I said K will form +1 ion. Sodium will form +1. Calcium would form +2 because its valence is +2. Magnesium will form +2. Aluminium will form +3. So this is how you find it. So the valency and charge are two different concepts. But valency is mostly equal to the charge that the atoms form. That is, calcium's valence is +2. So when it forms an ion, it forms calcium 2+. This side, it forms this side. So this would be equal to this most of the time. So that's why I said it for you all to remember it easily. So, when we consider, so there are polyatomic anions also, polyatomic ions. Polyatomic ions means like OH minus. So when we consider the valence would be -1 because that would be equal to this, okay? And other polyatomic anions, the positive anion is like ammonium, NH4 plus. This is ammonium. So the valency of this would be +1. It would be equal most of the time. Okay, these are polyatomic ions. Polyatomic ions means there are more than one atoms combined to form an ion. That is polyatomic. Right? So this is what comes under the periodic table. And we can get even more information from this. The group number represents the number of electrons in its valence shell. Mark all these number of electrons in the valence shell. Group number represents the number of electrons in the valence shell. Valence shell is the last energy level of an atom. For example, if I consider lithium, lithium has two energy levels. How can I find it? By using the period number. So the period number gives the number of energy levels. Period number gives the number of energy levels. So lithium has two energy levels here. Okay, so I found it using the period number. And now lithium has three electrons. How did I find it? Because its atomic number is 3. 1, 2, 3. The lithium has 3 protons and 3 electrons when it is in the atom. So when it is gaining or losing electrons to form ions, the electron number will be changed. But when it is in the atom form, then the number of protons and number of electrons would be equal. So lithium has 3 electrons because its atomic number is 3. Okay, so 3 electrons. So if I write the electronic configuration of lithium, lithium has 3 electrons. You know the number of the energy levels, the first 4 energy levels, they can be named as K, L, M, N. In the first energy level, there can be a maximum of 2 electrons. In the second one, there can be a maximum of 8. In the third one, there can be a maximum of 18. In the fourth, there can be a maximum of 32. But you know, when we fill these energy levels according to the electronic configuration, we don't consider it as 18. That means we don't fill up to 18 here. We fill up to 8, like the energy level L, and then we jump into the other electron, other energy level. Sorry, other energy level. And we fill the other electrons to that energy level. So we fill maximum up to 8, even though it can be filled up to 18. And then we go to the next energy level. So remember this. So lithium, it has two energy levels, it has 3 electrons. So the electronic configuration of lithium would be 2, 1. 2 in the first energy level, maximum, and the next one would be going to the second one. So therefore, there are 2 energy levels. It is having 1. It is having 1 electron in the valence shell. Therefore, the group number has become 1. So, you know, if you write the periodic table, it would be very easy for you to get so much of information. You don't have to struggle. So, the group number, it will give the number of valence electrons, and the period number will give the number of energy levels. So, if I consider another example, chlorine. So, chlorine's atomic number is 17. If you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so it comes to 17. Okay, so 17 means in the atom form, it has 17 electrons and 17 protons. So 17 electrons has to be filled in these respective energy levels. So the electronic configuration of chlorine would be 2, in the 2 maximum for the first one. Next 8 would be going to the second one, then it would be 10, add up to 10. And the next 7 can be added up to this one, M, 7. If there is 9 remaining here, we can add up to 8 and we can put the other one to the next one. Okay, so we can fill up to 8 here, only 8, and we are writing the electronic configuration. So 7. So here there are 3 energy levels, and this can be easily got by the period number, 3 energy levels. And you know there are 7 electrons at the final energy level, that is the valence shell, which is called the valence shell. Only these electrons will be forming the bonds. They will be involving in forming bonds, and therefore they are called the valence electrons. The electrons in the final energy level or the valence shell can be called as the valence electrons. So as there are 7 electrons, the chlorine is under the 7th group. So you can mark these. The group number gives the number of electrons in the valence shell, and the period number gives the number of energy levels. And you can write this valency. Okay, you can color these nicely. And also we can quickly overview about the first ionization energy and about the electronegativity. Okay, electronegativity. So what happens is, when we go from left to right of the periodic table, you can mark an arrow like this. You can mark an arrow like this. When we go across the periodic table like this, from left to right, the electronegativity as well as the first ionization energy both will increase. Both will increase. And when we come down, you can mark an arrow like this here. Right. So if I mark an arrow like this, when we come down the periodic table, the electronegativity and the first ionization energy of elements both will decrease. They both will decrease. Okay, so electronegativity increases, first ionization also increases going across, and the electronegativity and the first ionization will decrease when we come down. So by that we can identify that electronegativity, the highest electronegativity and the highest first ionization energy can be found. So when we're going down, it will decrease, no? When we're going across, it will increase. Okay, so the electronegativity is actually attract the electrons, no, attract the bonded electrons. Will noble gases like to attract bond electrons? No, they never like, because they don't want electrons. They don't form bonds. Their valence is zero. So therefore, when we consider the electronegativity, we are not considering the noble gases. We are ignoring the noble gases. Okay, because their electronegativity is zero according to the Pauling scale. They do not like to form bonds. They do not like to attract electrons. So if we ignore that, when we consider the others, hydrogen will have the highest electronegativity. Sorry, fluorine will have the highest electronegativity as we go across the group. As we go across the group, the electronegativity is increased and we ignore the noble gases. Therefore, fluorine will have the highest electronegativity. Okay, and when we come down, the electronegativity is decreased. So here, the fourth period would have the least electronegativity. And in potassium and calcium, as we go across, the electronegativity will increase now. So potassium will have the least electronegativity. Calcium would have more. So fluorine would have the highest electronegativity, and the potassium will have the least electronegativity. And when we consider the first ionization energy also, for the first ionization energy, we can consider the noble gases. Okay, so the first ionization energy is the energy that should be provided to remove an electron, remove the final electron of an atom. So the first ionization energy also increases this way and it will decrease. So that if we find using that way, then helium would have the highest first ionization energy. Helium would have the highest. The first period would have the highest compared to the other periods, because when we go down, it will decrease. And when we go across, helium will have the highest than the hydrogen. So helium will have the highest first ionization energy. And same like the electronegativity, potassium will have the least, because when we go down, it will reduce. And also, this is in front of calcium, which means it has a lesser first ionization energy compared to calcium. So potassium will have the least electronegativity as well as the least first ionization energy. While here fluorine will have the highest electronegativity, helium will have the highest first ionization energy. Okay, so that is a quick overview about the periodic table. And then, all clear, right? Is everything clear for you all? Can you all respond me, please? Is everything clear? Okay then. So as a final part, before we finish the class, you all are not responding, so therefore I cannot keep this rapid fire over here. I thought of keeping a rapid fire. Okay, now I'll send a picture in the group, okay, Elevate Academy group, the webinar group. So just go through it. I have given some questions in it in a funny way. It's very interesting. So you all can answer. If you all can, when I ask you all can reply to the chat. So can you all check what I have sent in the group? So there I have written, I have written the descriptions about some of the elements from the first 20 and also one last one out of the first 20 elements. And I want you all to guess the element according to the properties given. So which is called the who am I. So the elements are asking, who am I? Okay, so if you all respond, it would be better. So before finishing the class, we'll just revise about these elements in an interesting way, okay? So the first one. So the first statement says, so they are in the above the questions I have given the periodic table that is for you all to complete, and you know I have given the arrows and all to write about electronegativity, first ionization energy and all. And then, so in the first one says cold water, no, not my time, hot water only. I burn with a dazzling white flame. Okay, so this person is saying that cold water is not his type. He likes to react only with hot water. And it burns with a dazzling white flame. It has a white flame. Who is that element? Can you all guess? Can you all guess the element? Quick, quick. Who likes to react only with hot water but not with cold water? If you know, you all can respond. Even if you don't know, you all can respond like according to your guesses. I'm not receiving your messages. Okay. Please text to the MG. Exactly. Excellent, Ahmad. Excellent. So Mg, magnesium. Magnesium doesn't like to react with cold water. It always likes to react with hot water only. Okay, so it reacts with hot water, but its reactivity is lesser to react with cold water. Okay, and also it burns with a white flame. It has a white flame. Okay, when something is burning, when we are saying that an element is burning, that means it is reacting with oxygen because oxygen is needed for burning. So it reacts with oxygen to form its oxide, MgO, oxide. So if we balance it will be like this. So this is a white powder actually. It is a white powder will be formed. And the flame would be in white color. It will burn with a white flame, magnesium. Okay? So yes, that's about magnesium. And if I'm talking about the other flames, you know, sodium. Sodium has a yellow flame. That's why it is used to make in the production of the sodium vapor lamps, the street lamps which glow in yellow color. So it has a yellow flame. When it burns with a yellow flame. Okay, and then what else? Sulfur. In your syllabus, you have these three flame colors. So sulfur is blue color. It burns with a blue flame. So mark this somewhere. Magnesium burns with a white flame. So draw it, color it nicely. So sodium burns with a yellow one. Sulfur will be burned with a blue one. So sulfur will be forming SO2 combined with oxygen while it burns. Sodium will be forming its oxide, Na2O. Okay, so sodium is the one which is used to make the dyes which are used to color the denims which you all wear, the blue color, indigo color denims. So sodium is used for that. Sulfur is a non-metal. These two are metals. You know, sulfur has electrodes. What are electrodes? There are crystalline forms of sulfur. There are amorphous forms of sulfur. Crystalline forms are like the solid ones. Amorphous are all the solid, but they are like brittle. They are in the powdered form or something like that. So this one has electrodes, sulfur. It is a yellow color solid, no? So sodium is stored in the paraffin wax to protect it from reacting, because you know here in the activity series it is very high, it is very above. So which means that it has a very high reactivity. So therefore, to protect it from reacting with the air, it is stored in the paraffin wax. Okay, so those are the things which I needed to remember. And also sodium can be cut with a knife. It is very soft. It can be cut with a knife nicely. It has a very low density, therefore it floats in water. But magnesium does not float in water. Magnesium has a higher density than water and sodium has a lower density than water. Right? And the next one, the second one. What is the second one? The second one, I roam around as a triple bonded gas. Okay, so it is a triple bonded gas. Triple bonded gas. And I show off my oxides during lightning. So it's forming oxides. And it shows off during the lightning process. Who is that person? Who is it? Nitrogen, exactly. Excellent, Ahmed. So nitrogen. So others can also answer, only Ahmed is answering. So that is nitrogen. So nitrogen is bonded with a triple bond. And it forms oxides during lightning because it has triple bond. It is very less in reactivity. It is so hard to break this bond. So during lightning and other processes, when there is an electric arc, it uses the energy provided to break this bond. And then it forms its oxides. The nitrogen's oxides are NO and NO2. It forms NO and NO2 during lightning. It combines with oxygen to form NO, and that will combine with more oxygen to form NO2. So nitrogen is very less in reactivity, but it is also the most abundant gas in the atmosphere. It is also the most abundant gas in the atmosphere. 78% is nitrogen. Okay, and then what else about nitrogen? Nitrogen is used as a blanketing gas. It is used as a blanketing gas. Blanketing gas means it is used as a blanket to protect something from becoming reactive. You know, if I have something that shouldn't be reacted with the air, then I can cover it with nitrogen gas. So the nitrogen gas is very less reactive now. So therefore, this object can be protected from reacting with the air or something like that. So it is used as a blanketing gas. Okay? It is used as a coolant too. Nitrogen can be used as a coolant. It is a triple bonded one. And then the third one, I built the hardest lattice on earth. So this person built the hardest lattice. What is the hardest lattice on earth? And yes, I am the only non-metal that conducts. Non-metals, they do not conduct no usually. Only the metals, they conduct heat and electricity. But only this non-metal conducts. Who is that then? Quick, quick. Carbon. So yes, carbon. So carbon is the hardest lattice that forms this diamond. And then it also forms another electrode called the graphite. These two are crystalline. These two are crystalline compounds. This graphite can conduct electricity. And this diamond is the hardest lattice. So in the diamond, carbon is connected to 4 other carbons, and in graphite, it is connected to 4 other carbons. In graphite, it would be connected to 3 other carbons. And the graphite will form layers. Like these 2 layers, 3 layers will be there, and between these 2 layers, there are weak forces. The forces are very weak. Therefore, this can be used as a lubricant also. Graphite can be used as a lubricant also, like grease. Diamond is used to cut glasses and all because it is very hard. So carbon is the only non-metal that conducts electricity. Right? So good. And the fourth one, my oxide can't choose sides. So this one's oxide cannot choose sides. That means that that person is amphoteric. It is not basic. It is not acidic. The oxide is amphoteric. Amphoteric means it has both the characteristics of base. It is both basic and acidic. And also, and my chloride lives with an incomplete octet. Chloride lives with an incomplete octet. That means the octet has not been completed in the covalent compound. That means that should be a covalent compound. And its chloride's octet is not completed. Who is that? Aluminium, exactly. Yes, aluminium. So aluminium is not basic, it is not acidic, it is amphoteric. So aluminium's chloride is this, AlCl3. It combines like this. This is aluminium's chloride. This is aluminium's chloride. So here, the octet around aluminium is not completed. Because here there are 2 electrons, 2. Here there are 2 electrons, 2. Here also there are 2 electrons, 2. These are bond pairs. These are lone pairs. Only valence electrons are considered in drawing the Lewis structure. So here there are only 6 electrons surrounding the aluminium, not 8. Therefore, octet is not completed. Octet is not completed. What is the person, which is the person whose octet is exceeded? Who is the person with whom the octet will be exceeded than 8? Who is that? In someone's chloride, the octet will be exceeded. Who is it? No. No, actually it's not fluorine. It is phosphorus. It is phosphorus. Now, phosphorus chloride it combines with 5 chlorine. Okay? It combines with 5 chlorine to form this kind of a chloride. So here forms this kind of a chloride. Here 2, 2, 2, 2, 2. There are 10 electrons surrounding phosphorus. So here the octet has been exceeded. That means the electron is greater than 8. So that is phosphorus, PCl5. Aluminium forms AlCl3, the chloride. And yes, aluminium is amphoteric. When we are considering the basic, acidic or the amphoteric nature, we are talking only about the third period. Only about the third period in your syllabus. So when we consider the third period, in the third period there is sorry, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So this is the third period now. So here aluminium is amphoteric. This is amphoteric. And anything that is left to aluminium, those are basic. Those are basic. And anything that is, sorry, the sodium. So those are basic. And anything that is right of the aluminium, they are acidic. So all these are acidic. So we are not considering the argon. Argon is a gas actually. So that means not actually I'm not talking about the elements here, the oxides they are forming. I'm talking about the oxides that they form, okay? Elements we are not classifying as basic and acidic and all. We are talking about the oxides here. So sodium forms an oxide which is basic. Sodium and magnesium, they form basic oxides. Aluminium form amphoteric oxides. And all the others here in this side, they form acidic oxides. So what happens is the acidity increases and the basicity decreases when going across. So this will be strongly basic, and this will be weakly basic, and then amphoteric. Then this is very weakly acidic, strongly acidic, very strongly acidic. That's how the pattern varies. The acidity increases and the basicity decreases. Strong base, amphoteric, very weak acid, strong acid, very strong acid. So these are the oxides. I'm talking about the oxides. Na2O, MgO, Al2O3, SO2, Cl2O5, about them. Okay? So yes. And then, what is the fifth one? I am a flammable diatomic gas. That means I'm combustible. Flammable diatomic gas. And also, you can collect me by pushing air downwards. That means you can collect me by downward displacement of air. Who is it? You can collect me by downward displacement of air. Who is that gas? That is hydrogen. That is hydrogen, H2 gas. H2 gas is less denser than air. H2 gas is less denser than air. Therefore, the air will move downwards and H2 gas will move upwards. That's why you can collect hydrogen gas by downward displacement of air. And it is a diatomic gas. It is combustible. It is combustible. Okay. And the sixth one, just 5 minutes more, bear with me. And sixth one, no combustion without me. I am born when a purple solid is burned. No combustion without me. That means who is needed for combustion? Oxygen gas is needed for combustion. So there is no combustion without oxygen gas. So whenever if they are saying that an element is burning or if there is combusting, that means it is reacting with oxygen. And I am born when a purple solid is burned. Okay, who is that purple solid? That is a condis, which also known as the potassium permanganate. You know, you can burn this potassium permanganate. It will undergo thermal decomposition reaction to produce K2MnO4 plus MnO2 plus O2. Okay, K2MnO4, MnO2 plus O2. So here oxygen is produced. There are several other ways to produce oxygen also. There are 4 ways to produce oxygen in your syllabus. Either by burning this or KClO3 can be burned. That will produce KCl plus O2, or else KNO3 can be burned. That will produce KNO2 plus O2, or else H2O2, hydrogen peroxide can be burned. H2O plus O2. Okay, so these are the 4 ways. So oxygen gas is actually higher density than air. Therefore, you can collect it by using upward displacement of air. The air will move upward and the oxygen will move down because it is it has a high density. Okay, and the 7th one, I flexed as the most reactive one. Okay, you can get it now itself. Who is the most reactive? This one. The most reactive one is potassium. But they mock me for having the lowest electronegativity and first ionization energy. Of course, the lowest electronegativity and the first ionization energy, we found that it is also potassium. So potassium has the lowest electronegativity and ionization energy, but it is the most reactive one. And then the 8th one. My carbonate crystallizes first in salt pans. Whose carbonate crystallizes first when you are forming in the production of salt? Calcium carbonate crystallizes first. So they will be having three tanks now, the first tank, the second tank, and the third tank. In the first tank, calcium carbonate will be crystallizing. In the second, it would be calcium sulfate. In the third only, there will be sodium chloride when in the salt production. So my carbonate crystallizes first in salt pans means that means he is calcium. And pull the milky lime water trick with some gas. Okay. So calcium carbonate is the one which is responsible for making the lime water. I mean, it makes the lime water milky. That means what happened is this is lime water. Calcium hydroxide is lime water. Sorry. Calcium hydroxide is lime water. When it reacts with carbon dioxide gas, what happens is calcium carbonate will be formed. Calcium carbonate plus water will be formed. So this makes the lime water milky. That is a distinguishing test for carbon dioxide. So the milky lime water trick is formed by this calcium carbonate. Okay, so the calcium is the person here. The ninth one, I escaped during sodium production. I escaped during sodium production. Actually, when you see the sodium production, they're using sodium chloride liquid for sodium production. Okay, so in that sodium will be produced. By the way, chlorine will also be produced, chlorine gas. So it will escape during the sodium production and it is used for bleaching. And also polyvinyl chloride PVC polymer is also formed by chlorine. Polyvinyl chloride is a polymer of polymer of ethyl chloride. You mean the chloroethene. You say the chloroethene. This is chloroethene. So this polymerizes to form PVC. So there is chlorine here too. So it helps to make PVC, chlorine. So chlorine gas is the answer. And then final one, not in the first 20. Okay, so this person is not in the first 20 elements, but it's in your syllabus, okay? You can't say no. So, not in the first 20, but I change colors in water. There's a CCl4. It changes colors in water and CCl4. That means it makes two colors, one in water and other one in CCl4, which is a carbon tetrachloride. And then it gets separated by solvent extraction. Okay, so this is a separation method, solvent extraction. Which compound do you separate by solvent extraction? That is iodine. Iodine. Iodine solid can be physically separated using the solvent extraction. This iodine solid is like, it is a solid. Iodine exists as solid at a room temperature. So this has a color in water, some kind of a purple color, a violet color. In CCl4, CCl4 is a non-polar compound. So in CCl4, it changes color. Sorry, in water, it is some kind of a yellow-brown. Yellow-brown. In CCl4, it becomes purple. It becomes purple. So in solvent extraction, what they do is they extract the iodine dissolved in water to CCl4. Because iodine is also non-polar, CCl4 is also non-polar, it is more soluble in CCl4 than in water. So what they do is they mix water and CCl4, but they do not dissolve with each other. They do not mix with each other because they are immiscible, CCl4 and water. This is polar, this is non-polar. And they mix together. So what happens is the I2 which is dissolved in water will move to CCl4. So the yellow-brown color of this will become pale and this will become more purplish because the I2 gets dissolved in CCl4. Okay, so that's the process called the solvent extraction. That was they separate I2. So yes, that was iodine. Okay, and then you know the solvent extraction, the two liquids cannot be miscible. The two liquids used cannot be miscible. And also the two liquids should be in contact with each other, like this. The apparatus will be used like this for solvent extraction. Some kind of this apparatus, and here there will be, imagine this, here there is water with iodine and here CCl4. Then they mix. They do not mix, okay? They are, they are shaken together. Then when they are shaken together, what happens is, as iodine which is dissolved in water is more soluble, it moves here. This will become purple and this will become pale. So they will be in contact with each other. These two should be immiscible, and also the solute should be more soluble in one solvent and less soluble in another. So that is the solvent extraction process. So that is for iodine. Okay? Okay then. I guess we are done for the day. Is everything clear for you all? Thank you for staying with me. Is everything clear for you all? Okay, right? You all can text me if you have any doubts now. Okay, then that's a wrap for today. I hope you got something valuable from this session, and also um, keep revising what we went through today. Do it within 24 hours. Do the questions. Do all the examples that comes out of the electrochemical cell and the electrolytic cell. Try it again and again. Then you will get that. You will catch that concept. Okay, and most importantly, believe in yourself. Okay, we can enjoy and we can do this O level while we are doing the real work too. So let's keep the energy alive for the next one. So you can join the other sessions also, and we can have fun while doing this. Don't get stressed. O levels aren't scary. So they're just a challenge, and it's an easy challenge comparing to A levels and all. So yeah, don't get stressed on all. See you in the next seminar, and until then, keep learning and keep shining. Okay. Now you all can leave if you want to, and if you all have any doubt, you can also ask me.